Coffee stains and name of chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and name of chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Yo chat, what's up? Welcome back to the stream. More coding interviews like we do every weekend. What do you need to get my help on?
This is not a main thing, really I'm a coder. Coffee stains and name of chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not a main thing, really I'm a coder. Coffee stains and name of chains. I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.
Crack open the Celsius. We got a ton of coding interviews today. Like 4 or 5. And then tomorrow we got more. So hop on, learn some stuff. It's going to be a good weekend. What is this? Drinking a Celsius because a little bit tired. Didn't sleep that well. Had to wake up early for a haircut. SK, what's up? Yo, appreciate you being there from day one. Yeah, I started this channel, or I started really posting this channel only 9 months ago. So a lot of the people, they come on, they're like, yo, I've been watching you since day one. Which is pretty much like 9 months ago. But thanks for supporting the channel. Really appreciate you. Do you have a Discord group? Yeah, go into my channel. Go to my channel and check out my Discord group. I have a few things in there. Check out my channel. There's a link to the Discord. Also, if you want to book a coding interview, just go right there. How's everyone doing today? How's everyone doing? How's Saturday? How's Saturday for you? Hope you're having a good weekend so far. The weekend's just starting. I mean, take some time to relax. Take some time to spend with your family. Probably go touch grass, see the sun. But whenever you come back in and you want to see some code, hop on the channel. I'll be streaming. But I'll probably step outside tonight and just go for a walk or something like that. How's everyone doing? chat is extra quiet today. Let me fix up this thing. Not good, just surviving. Are you good, man? Why not good? Why not good? What can we do to make it great? Man, sorry to hear that, man. Sorry to hear that. Is it related to... Are there spots booked for today? Yeah, there's 5 interviews already. But if you go to the message that I pinned, you should be able to hop in. Or you should be able to book one for tomorrow. I have a slot. And I think the week after I have a bunch. But it's filling up real quick. Okay, what about the week after? Any tips on asking for referrals? Feel awkward asking people I don't know super well, and people I know well are in college like me. Yeah. Any tips on asking for referrals? The first thing about asking for a referral or reaching out to someone is just don't be shy. I mean, honestly, a lot of people won't respond. So, first off, what I did is I just spammed referrals too. But honestly, a lot of people didn't respond and actually give me referrals. But try to dive deep into your network and look and try to find people. I remember I got a referral from Amazon by just asking my dad, and he randomly knew some high school classmate who knew some guy, and then that's how I got a referral to Amazon when I was new grad. So you never know, you might actually know someone. So just start asking around, like, do you know anyone, and try to meet people, find people through your network, and then just try to find people just messaging people on LinkedIn. But try to be genuine about it. Go to networking events. Try to make genuine connections, but also just spam people. Like, who cares if you feel awkward? You gotta step out your comfort zone. I'm going through Blind 75 right now. I'm going to take a DSA class this fall as a sophomore. I'm doing Blind 75, a good way to get interview ready for internships. Yeah, I think Blind 75 is a good list to get you started, but the main thing with Blind 75 is those questions. That list came out 5 years ago, so companies have already used those and don't really use those questions anymore. So I don't know. Check out my list. This list that I created are questions that I've actually seen in coding interviews these days. Yo, Satsang. So you graduated a year ago and you're just a little bit stressed that you don't have a job right now? I mean, that makes 100% sense. Getting a job in this market is very, very difficult. But it's not impossible. I'm sorry, just checking the audio. Will we see a better market in the future? I think the market has already begun to rebound from what I saw. I know a ton of new grads who are actually getting interviews. I've already ran into a few people, a few subs on my channel, and they're telling me that they have interviews at like Notion, at like Meta. They have a people are getting interviews, but maybe it's just these Bay Area kids. It's over? I don't think it's over. I think the market is going to rebound because I still see software being important in the future. The way that software engineers are gonna work and perform their job duties, it might change and is gonna change. But I still think we need people who understand, who can think logically, who are trained to pretty much problem solve using code as their tool, like using programming as their tool. And just the world is just going to keep adopting more and more technology. A lot of the people growing up today, they don't know anything about technology, or they don't know a life without technology. So I feel like there's going to be a lot of jobs. Demand for technology is going to only increase. Demand for AI is only going to increase. And if you look at even software right now, there's so many inefficiencies with how software is built, how software is maintained. There's still hacks. There's still a bunch of bugs that cause the sites to go down. There's still so many things that could benefit from the use of software. There's so much opportunity left. I wouldn't say that software or tech is going to go anywhere soon. I think maybe the nature of the job is going to change a lot. I'm spending a bit of time this weekend actually thinking through how AI is going to affect the way we work based on what I've seen so far, and I'm going to make my prediction. But I think people are still going to have jobs. The nature of the job is going to change where I think people are going to start managing AI, or we're going to have AIs do things for us, and then we just manage. It's kind of obvious, but yeah. Instead of actually writing the code, the AI will be writing code for you. And not in the same way that we're just using cursor. What I'm meaning is, how do you think AI affects software engineers' salaries? Alright, give me a sec. My nose is a little stuffy. Check my thing. Nice, people are booking. Good stuff. How do you think AI will affect software engineers' salaries? I think I still don't understand why software engineers make so much money. I mean, it kind of makes sense because the companies, like these companies actually pay engineers a small portion of the money that they actually make. So Microsoft is $4 trillion company and it's paying their software engineers like 150K of that money. So I think AI will. I mean, there's two ways that. Honestly, yeah, I still don't understand why software engineers make a lot of money. I think it's based on the market. So before, honestly, it's really hard to find really good engineers. It's really hard to find good engineers. So that's why they're willing to pay for good engineers. So especially when you go to the Bay Area, they'll rather pay one really good engineer 350K versus four mediocre engineers 100K a piece. That's just the way that they like to operate. Because a lot of the times, I think what they're going for is like small but very productive teams. And when you just continue, if you have pretend you have a team of 10 engineers all making 100K and they're mediocre, that adds a lot of people that have to collaborate, a lot of opinions. Will that team perform better than just three or four engineers making 250K a piece that are really talented? I think this usually, from what I've seen, the smaller teams, that smaller team would probably outperform those 10 people. So that's probably one of the factors there. The problem is everyone is diving into software engineering because it pays more money because the causing the market to get saturated. Yeah, it is the case that people dive into software engineering just because it pays more money. But what I've noticed working here for 5 years now is that the people who did it for the money, they eventually will retire very early, or they'll stop. Like they don't last that long in the industry. Like the people who absolutely don't even like coding at all, but only did it for the money, I don't know where they're at right now. The people who maybe they did it a bit for the money, but they kind of like it, maybe they learned to like it, they're still around. But the people who really like it, and just the people who are really passionate about it, those are the people that you see are getting real big promotions really fast and moving up and just mastering their craft. So I think there's just a problem at the top of the funnel, or just getting your foot in the door has always been the hardest thing with any career. But yeah, it's even harder today because there's so many people first off trying to get in it for the money, and then now with AI, those lower level roles are kind of getting replaced. As in, I mean, do you really need a junior like the bar for a junior software engineer has to go up. If a junior software engineer could only write me unit tests, but Cursor could also write me unit tests, why would I pay that junior engineer 150K? And I'm not really an employer. That's just the way I think, the way that I think they're also think about it. Also, with every person you bring on the team, you have to consider the effect of bringing that person will have on the rest of the people on the team. So pretend you have a team of like four people who love their job, they love software engineering, they're super passionate about it, and then and then they're really good at it, and then you start bringing in a bunch of people who don't really care about it and they're sort of mediocre, and you bring them to the team. It's gonna really affect those people who are on the team before, who really enjoy doing their job and really enjoy like software engineering. You know what I mean? So like you have to think about the team dynamic. So what a lot of times, that's why you'll see that's why I think that's why they just take forever to hire a lot of times. Like it really takes forever to hire. Like I've been in so many interview panels and doing a lot of interviews on candidates, and it just takes forever to find a candidate to fill the role. But there's always an endless stream of candidates coming in, applying. So that's also why we a lot of the times, if someone is good but not great, we could just pass on him because we know that somebody is going to come in and eventually do good. But this is very specific to Silicon Valley. I don't know about other cities and how it works. Yeah, in a lot of the companies I worked at before, if it's a lean hire, as in you're barely passing this person, it's just not a pass. It's just try again in 6 months type thing. Like we need to be really sure. I mean, the cost of a bad hire is really costly. It's far more than just money. But team building is one of the most important part of building any company when it comes to tech companies, especially in a ultra competitive environment like Silicon Valley. Hiring is everything. Like my managers would just spend all their time hiring. I had a manager when I was working at an early stage startup. He came from Apple, So he thought that when he would come to work at this early stage startup, he's gonna be on the ground. He's gonna be like pushing all these like new initiatives, and he's gonna be, I don't know, in a lot of different things. But then he was literally just hiring people 40 hours a week. Yeah. Let's see. Okay, we got somebody coming on in 3 minutes, so I'll be done rambling. Any more questions? One more question until we go. Yo, chat, send me some like good questions to ask people too. Do I recommend starting my career at a startup? Yeah, I recommend 100% starting your career at a startup. Taj, what's up? And the interview started in 3 minutes. But okay, I'll tell you exactly why I recommend starting your career at a startup. The first thing is just the pace of execution is a lot faster in the startup, and there's way less bureaucracy. You don't have to coordinate with a ton of people just to get anything done. You're not like when you touch one piece, you're not worrying about six other teams that are very slow to respond. I feel like when the larger the company gets, you just have to talk to way more teams to get something done. And that's not a problem, but some teams take a long time to respond. I feel like when you're early on, you need to focus on repetitions, like being able to pump out features really fast and just get your reps in, seeing a bunch of features go end to end from ideation to production. And you don't want bureaucracy, I don't know if I'm pronouncing that right, to be bogging you down all the way through. And then also, I feel like working at a startup when you first graduate, the salary difference between working at a startup and a FANG when you first graduate is not that much. So if you ever want to work at a startup, if you start off at a FANG or a big tech company and work there for 10 years and think you're going to go move to a startup where you're not getting public stock, like the salary is going to be lower, I bet you won't do it. So the main chance or the like your chance to work at a startup is really when you graduate, because the parity of pay begins to increase a lot. So like a senior engineer at Meta or Google is making a lot more than a senior software engineer at a regular startup, mostly because of the stock. And yeah, but a junior engineer at a startup is usually making very close to a junior engineer at a big tech company. If I were to restart my career right now, what would I do? I would do the exact same thing that I did, because honestly, when I would talk to people, I've met a few people in person just walking around out here in SF, and they would send me their resumes, and they would tell me that they're able to land they're able to land interviews and stuff. So and the strategy that they took is similar to the strategy that I took when I first graduated. So I think if I were to graduate, I would still follow the same strategy. I don't think it changed that much. My initial strategy for getting a job. When okay, cooked if you graduate with no internships. Ideally, you should get an internship. When you were in college, did you focus on lead code only, or did you learn things as well, like web? When you were in college, did you focus on lead code, or did you learn other things as well, like web, backend, etc.? And out of these, in which you were really good? So when I was in college, I started college in 2015. I first really started lead coding in 2020. So the first 5 years, I didn't do any lead code at all. I just straight up tried to do projects. did a ton of different projects, and my main focus was doing projects and getting projects on my resume, and then trying to land internships. And a lot of those internships were at local companies. So I mean, yeah, that's kind of I. In order for me to break into Silicon Valley or SF, first, I'm not even from California. I'm from Canada. What I did was I was working. I would just apply locally to jobs in Canada. There's some jobs there, and I would just my main goal was just trying to get any work experience on my resume, whether it be research experience, whether it be like a $15 an hour government job, whether it be like just anything where I can say that I worked on software, right? And once I got a few things under my belt, that's when like Silicon Valley companies started giving me the chance to interview. And when they started giving me the chance to interview, that's when I started studying lead code. But I think the first thing is I would only study lead code if I have an interview that's gonna ask me lead code. Other than that, it's pretty much a waste of your time, and you just need to find a way to get an internship by building your resume, talking to people, working on projects. Try to get the best marks you possibly can during school. There's other ways that you should land your interview. Only when you get your interview is when you should do lead code. Unless you know you're gonna get interviews, then you should start doing lead code. But I didn't even know I was gonna get interviews, so it felt useless to study lead code if I knew I wasn't gonna get interviews. Does that make sense? Bro, honestly, I was just kind of doing things I was passionate about. Like I was a bit entrepreneurial, so I took software engineering or computer science because I wanted to build tech companies. So I would just see problems in the world, and then try to build code that will solve that problem. So thank you. Like for example, I'll give you one example of a project I spent like 2 years working on. So this is a project that I spent like this is what's even before I was doing lead code. This is one of the things I was working on. This is like a research paper that I did at my school. But basically I was building an AI to detect what workout people were doing and count repetitions. So basically my vision was when someone walks into the gym, they should be able to do their workout and without having to walk around with a pen and paper or app tracking all their workouts. They could just walk in, then walk out, and then they should get a detailed report of exactly what they did at the gym, how many reps, how much weight, etc. So the next time they just come in and they do progressive overload and get stronger. Basically, the premise is what gets measured gets improved. So if you measure your workouts, you track your workouts, you'll continue to make progress because you'll push yourself just a little bit more every time at the gym, right? So I initially like me and my friends would like came up with this idea. So I would just first off in order this was 5 years ago I wrote it. I dropped this paper, but even just 2 years before that was when I first started working on it. So basically, yeah, I learned a lot from trying to make this thing happen in real life, like bringing this thing to a reality. Like I read my first machine learning textbook because I was like, how are we gonna do this? So I didn't know anything about AI, so I had to read a machine learning textbook. Then I had to start trying to implement the code. Then I had to like gather data by talking to friends and running like data drives to get data. Then I figured out like how to label the data, then how to train the models on the data, how to write the research paper. Like there's so much things you learn from it. So I don't know. What I would suggest is just try to find problems in the world. This one was a little bit motivated by money because I thought that if I solved this problem, I could get rich. So that's kind of what drove me. I mean, obviously it didn't work out, but there's so much stuff I learned from this. So that's what I'm saying. You just don't chase the money. Okay, we have the next. Does that make sense? Okay, we got the next guy in. Mars, ready? Yo, chat, send me some stuff some interview questions. What kept you motivated to keep doing that project? Probably looking back on it, like delusion. So I thought that if I built this project, I was gonna get rich. So I just kept grinding on it, and I found it fun too. I wanted to work on a project. It was a good idea. I thought it solved a problem that I had for myself. But I think when it comes to anything, trying to achieve a lot of things, having a little bit of delusion goes a long way because you really need to believe in yourself, especially when times get hard. And even right now, I'm probably like delusional on some of the goals I have, but I don't care. Mars, what's up? Motivated?
Hi, James.
Mars, what's up? Oh, wait, I'm answering. How did you handle the burnout? Yeah, exactly. Alpha, it's better being delusional, thinking you can't do anything. But also, you don't want somebody really delusional, to be honest. But how did you handle burnouts? The lucky thing about me is I just don't burn out. Honestly, I remember when I first started in my career, I was talking to my manager because I was working a lot of hours, and I was asking her like, should I be worried about burnout? Should I like tone it down? And she just told me like if you're not burning out, then don't worry about it. For her, she's worked in the industry for 15 years and she doesn't really get burnt out just coding, but she did get burnt out when it came to like bureaucracy and things related to that. So, I mean, some things will burn you out quicker than others. For me, just writing code, doing lead code question, it just doesn't burn me out. But maybe if I had to do other things, it would be more annoying and I would burn out. Mars, what's up, man?
What's up? You good? Can you hear me?
Yeah, how you doing today?
Good. What about you?
Pretty good. I'm pretty good. I'm pretty good.
Good.
Did we? Hold up. Let me grab. My nose is a little stuffed.
Yep.
Nah, not a monster. All right, I'm gonna send you the link. Thanks for hopping on, Mars.
Thanks for having me.
Alpha, I got a good question for you later.
Yeah.
Like Alpha is coming on next. I already asked two people this question. They failed it. Alpha will probably get it, but. All right. Okay. Let's check this out.
Join. Get started. Okay, great.
Hey everyone. So today I have somebody from Stockholm, or you're initially from France, but you are in Stockholm. You're working in Panama.
Yeah,
Oh yeah,
I
just
was the
introduce
guy in
yourself real
Panama.
quick.
Yeah. Yeah, but basically, I'm a French student, and I'm doing my
Nice.
exchange in Stockholm for 6 months, and I was doing my summer internship in Panama. So yeah, I'm moving a little bit right now.
Yeah, you're
But
everywhere.
it's great.
350 lead code questions. That's wild.
Yeah.
Did
Yeah,
I run
grinded a
it?
bit since.
Did I run an
Yeah.
interview on you already or no?
Yeah. A few weeks ago, I was stuck on like matrix traversal in spiral order. Do you remember?
Oh, okay. That's I asked you. You weren't able to get that one.
Yeah, I
Okay.
was doing some shitty stuff with like four loops, and yeah, basically just done it afterwards and was able to get it pretty easily without the stress and all that.
Yeah. It's always harder under pressure, and if you just
Yeah.
see it for the first time, like you go one approach, and it's hard to go back to another approach. It makes sense, but yeah, I remember you sent me the code after, and it worked perfect. Okay, let me think for a second what I should ask you then. Just give me a second. I'm just gonna quickly look at my GitHub or my lead code. Alberto, yes, you can get a interview after. Just book in the link that I pinned. You can book. Can we know some personal stuff like your setup? Dude, I just use a Magic keyboard. I use a MX Master mouse. I have a MacBook M3 Pro. Okay, let me find you some good questions.
Yep.
So what is off limits for you?
I don't know. Like today, I've done like the bi-weekly contest on lead code, and like I always can do like the last question, the last hard question. Today it was some DP, some 3D DP, and I was like stuck.
Oh,
So
you're doing the competition?
yeah, that's pretty pretty silly, but I'm like pretty near like to have a badge, and I want
Wow.
that badge so much that
Yeah,
doesn't mean anything, but yeah.
that's crazy. So you've already done a lot of the weekly like questions 1 to 3, so I can't really ask you that.
Well, yeah, I've done like
Yeah, because you've already had,
4 or 5 weekly, yeah. So
because you've already done those questions, right? I don't want to ask you questions you've already done.
yeah, the bi-weekly contest for today, I've done the first
Oh,
3.
you do bi-weekly or weekly? Because there's two.
Today was bi-weekly for me. I can do the weekly. It's 4 a.m. for my time zone,
Okay.
so I'm sleeping.
All right. Perfect.
But yeah, because for the time zone was convenient.
Mm-hmm. One sec. Okay. All right. I'm gonna throw in the first question. We're gonna solve 1 to 2 questions. Yeah,
Okay.
20 to 25 minutes each question. And I'll just drop in the very first question here. I'll let you go ahead and read that.
Okay. Given n by n, take a magic grid, integer x, y, and k. K, which parameters? Integer x and y represent the row and column indices of the top left corner of the square submatrix. K represent the size of the square submatrix. Just take the flip submatrix. I pretty remember that one. Didn't you've done it in live before? It was like a daily question, no?
I don't know if I did this on live, but yeah. What are you thinking?
And K, let me think. And K represent the side length of the square submatrix. Yeah, okay. I don't know if it's that question, but that was something like you just, yeah. let me put this in right order so we can see.
And if you've done it or it doesn't matter, just try to implement it. Like I don't know if I
Yep.
would say that to interviewer because even sometimes I thought I did the question, I didn't do the question. So yeah, I would just try it.
Yeah, okay. So here k equal 3. So yeah, that's this matrix here. Yeah. Okay. So let's just how can I name this function? That's the hardest thing. To flip the submatrix, I flip the submatrix. Okay, take a grid, which is a list, and just typing out the function afterwards. I will explain what's my approach. List with matrix. So basically this one. And retention. Okay, so basically on this example, we have to reverse this submatrix of 3 by 3 and starting at x equal 1 and y equals 0. Basically what I would do is to loop through coordinates and just calling maybe a helper function to just reverse the column based on the coordinates of this 5, this 6, and this 7 to reverse it with 13, 9, 5, 14, 10, 6, and so on. Okay, so basically I would just need to do one pass for each column.
Sure.
Okay, so return the updated matrix, not do it in place. Okay, just returning the grid at the end. Well, we can basically do it in place, but okay. Okay, let me think of just outlining the code. We'll need to catch the x and y here. Not very familiar with x and y. I would maybe use a and j. It's better for me. X equal 1, y equals 0. Well, let's keep it with x and y. Okay. So, okay, I need to start from the y equals value y in range y, and when do we end? We basically end at y plus k. Sorry, k. Okay. Do we include the y plus k? Okay, let's pretend y equals 0, k equals 3. We're going to 0, 1, 2. Okay, yeah, that's -1, but the range actually handle it. And what I'm gonna do, I'm basically gonna call my helper function, which is reverse column, I think. Yeah. Reverse call that would take what this function will take the coordinate, so the column, the row, just call it C and R, and also K, and the grid, obviously. Okay, so just implement that function, take the grid, take the column, take the row, take the K, and return basically nothing. Okay, the column, what's the column here? Let's just put a pass here. Okay, so our column here is the X, our row is the I, a K is K, and we can basically do with 2 pointer, one top and one bottom. The top will be at well, what did I put the X here? Okay, row column,
Sure.
column row K, would be at K. The bottom would be at C plus K, and while my top is less because I'm doing with coordinates, yeah, less than bottom, strictly or not, I don't think. No, strictly, because if if they are equals, we are basically done. Yeah, just flip those grid of top. Okay, let me think of the coordinates here. We want this one basically and this one. So yeah, that's top and that's row here with grid of bottom of the row is equal to bottom okay type, sorry. Of the row, and we just update our pointer. Oh. Top plus equal 1, bottom is equal 1. Okay, let's maybe add the type here. That's an N, that's an N, that's an N. Okay. Maybe, okay, I didn't ask the question, but if grid is none, if is null, we can handle that case, but okay, just return none. Basically, yeah, just looping through those coordinates here. Y plus k minus 1 with the range, and reversing all the column. Turning on is useless. Return, oh yeah, type hinting on here. Okay, let me think of the parameters here. The grid, it's okay. The column is the x equal 1 here. Is actually the column that I put it here. Column and row. X is like, oh. Y equals to 0, x equal to 1 here, x doesn't move, right? Yeah, I must have messed up those. May do I and J. I'm really more comfortable with I and J because here this really messed up my mind. I, J, so it's J. Sorry, it's I here. I grid in here, basically J. Okay. So here I'm passing I and J, top, bottom. Yeah, those are good, but those parameters here, for I, it's X, I is X, I plus K. What am I passing here? I and I plus K. Yeah, okay, and the Y, I'm looking through it.
Okay, let's drive on me the code, like we talked about them.
Yeah, so let's take this grid and let's just copy it right there. So let's add some space to our pointers. So basically we are looping through Y and Y plus K here, which is 0 and like 0, 1, 2. Okay, so and keeping the X coordinate here. So we are basically looping through those one. How I can little pointer, yeah. Just call. So we are putting our top pointer and I and bottom I plus K, which is I is actually the X. Yeah, the naming isn't that so good. I can put J here. That would be better. So I is the X. So we are going through one, which is here. And top would be a I plus K, so 1. Oh, okay, I may have an indices error here, maybe -1, because that was handled by the range, but not here. So that would be X, which is 1 plus 3, which is 4. Yeah, -1 is 3, it's better. So it's at 13 and the other has 5.
But it's inclusive, right?
Here.
Or
I
the while loop is exclusive.
Yeah, but I may get at the first iteration an out of range error because I'm accessing grid.
Mm-hmm.
So yeah,
For bottom.
I'm
Okay.
basically switching those. Top bottom equals bottom top. Yeah, good. And just putting like 13 here and 5 here, incrementing my pointers, which are here
Mm-hmm.
and basically they are equal, so we don't move these 9. Yeah, okay, seems good. That's for the first column, and after that I'm just looping through my J, incrementing by 1 and passing through the 6 here and basically doing the same thing. Okay, yeah. Time complexity wise, it would be like only the square, the little square that we have to reverse the reducible matrix. So yeah, it would just be like k squared actually, k by k squared.
Mm-hmm.
Okay.
Okay.
Um,
Okay.
Let me
Run
think if
it
I have.
on and see if it produces the right result.
Yeah, just let me copy this. Go to grid. No, it's image grid. Let's just res equal flip matrix grid x, y, 0, and 3. And just print res. Run. 1, 2, 3, 13, 14, 8, 9, 5. Is it the integer result? Yeah, I think 13, 9, 5, 14, 10, 6. Yeah, seems good.
Nice. Okay, cool. Let's see. Let me get you the next question. 1 second.
Yeah, no problem.
All right. Here's the next question. Just gonna comment this out. Take a second to format it.
Okay, so okay, you're given an integer array num of length n, where num is a permutation of the number in the range 0 to n.
Sorry, did you cut out? Sorry. Oh, okay, you're still here.
Yeah, sorry, my connection isn't too good. Yeah. Return the maximum value of k such that the array can be sorted in non-decreasing order using any number such swap. If none is already sorted, return 0. Okay, so let's walk through the example to understand a bit better. 0, 3 to 1, so that's not sorted. Okay. I have k, choosing k equal 1, swapping num 1 equals 3 and num 3 equals 1 is allowed.
Let me just explain it at a high level, because it's
Yeah.
a bit confusing. So we're pretty much gonna be given an array of numbers with the length of n, and then the values within it are going to be from 0 to n minus 1, right? And
Okay.
your goal is to figure out, like, at the end of the day, we want to get it in sorted order, but we can only swap elements. We can swap elements basically if we take the and of them and we get a k. Like the k is the non-negative integer where, like, if we take an and of them, we get some k, then we could swap those. So we just need to figure out the maximum k value that we can use in order to sort the whole array.
Okay.
Yeah.
Okay, so basically, okay, seeing the examples, I see like at most one element is swapped. Can we have more than one? Oh yeah, because it's a, no, okay, it's a permutation. Okay. So yeah, here we have, okay, 3 2 1 0 1 3 2 0 3 2 1. Okay, with the bitwise n, yeah. So here they're choosing k equals 1 because 3 and 1. Okay, they're basically the numbers we need to swap, and the only numbers here, and that with bitwise end is 1. So yeah, basically choosing 1. Here, we need to swap the 3 and the 2. 3 and 2 is allowed, and we output 2. Okay. Here we have 3 2 1 0. No greater k. Allow sorting, sits no greater k, allow the required swap when num I and num j equals k. The k equals 0. Okay. But this is case because return 0 if it's already sorted. But in this case it's not sorted. It's no greater k, allows required swap. Okay, so in the last example here, we cannot sort the array, so we just return 0. Because like they said, because if I do a bitwise AND with any number and 0, we have 0, right? So the required swap when I and j equals to k. We allow sorting.
If k is 0, so basically all of these numbers are not in the right slot. So we need to put them in the right spot. So in order to get them in the right spot, if we choose k equals to 0, we can pretty much move them all to the right spot.
Okay, let me. Okay, I think to walk through this one step by step. So, okay, if I swap, may swap element at this k equal, and this does not bitwise n. Okay, so if I take those extreme 1, 3, and 0, I swap them because k, the bitwise n to 0. Okay, so that's 3, 2, 1. Okay, and
Where are you
after
typing?
that, in the bottom here,
Okay.
below the third example.
Sure.
Trying to understand the last example. So just swap those extreme ones, the first and the last, with bitwise of 0 because we have 0. So
Let me
anything
just work through
and
the
0.
example 1 first. I think that one is good, and then we can work through example. Does
Okay.
example 1 make sense? Why 1 would be?
Well, okay. Here we have like 0, 3, 2, 1. Swapping num 1, 3, and then 3, 1 is allowed. Yeah, basically swapping those two. Okay. And okay, like yeah, because 1 is like just 1 and 3 is 1, 1. So yeah, and basically doing 1. So okay, k equals 1. But is there a way? I'm trying to figure out a way to find this k efficiently, not just to try all the possibilities. Okay, so k equals 1 makes sense, but we actually need to find first which element need to be changed, swapped. So okay, here it's, I mean, looking at the array, it's easy for us, but yeah, for a program we need to find the logic. Okay, for the second example, we have 0, 1, 3, 2. Okay, so here that's the 3 and the 2, which we need to swap, and the end produces 2. Okay, so k equals 2. Yeah. So, okay, in both of those examples, the end value actually was the lower value of the element we need to swap. So here it was the 1, here it was the 2. But I don't know if it's really, how can I say it? If it's really consistent. If I take an x and y and x is greater than y, I don't know if the end of the 2 will always be y. I'm not sure of that. Okay, so back to the example 3 here, where we need to do
Sorry,
more than
I don't see your
one.
cursor moving. Like,
Oh
are
yeah,
you touching
maybe
a?
I need to refresh. I refresh the page.
Yeah, refresh the page. I don't see where you're looking.
It's loading. Okay, can you see
Yeah,
me
now I see. Yeah, I see it
here?
now. Yeah, yeah, that works.
Okay, yeah, that's me, man. Oh yeah, what I typed was deleted. Okay, great.
Interesting.
So yeah, we have basically the last example here that is basically in reversed. So that's pretty inconvenient for us because we need sorted. So the first thing that we can do, yeah, I need to figure out firstly a way to find those swap that we need to do. Um, yeah, I could maybe do something like bubble sort do actually, like take one invalid element and put it in the right place. But actually the exercise is about the end, the bitwise end, and we need to find this k. We don't need to sort the array. We don't need to return anything, just the k.
Yeah.
So okay, here first, if I'm being logical, I would swap the 3 and the 2, which the bitwise end is 0, so we have this k equals 0 here. But afterwards, I need to fix this 2 and 1, which are not in right order. But the end is actually 1, so that's not the answer. I need to find another way. I need to keep playing with the 0 actually. How can I do that? Um, mm, mm, mm.
I'll give you a small hint. So
Yep.
we just need to worry about the numbers that are not in place.
Okay, the numbers that are not in place.
Yeah. Because
Okay,
if they're already in place, we don't need to swap them at all.
yeah, yeah. Basically, in the first example, like the 3 and the 1 wasn't in place, so we choose them. In
Yeah.
the second example, it was the 1 and the 3, and the last example is all the numbers.
Yeah. So for the first example, right, we only the 1 and the 3 are not in place, so we just need to swap them. So we need to figure out the biggest and value between them
Okay, yeah,
to make
okay,
that swap. And the biggest and value is pretty much 1. Well, like the only and value, because if you add them, you get.
yeah,
So yeah.
okay. So okay, basically with that hint, my approach would be to like do a first pass to find the elements that are not in their right place actually. So
Mm-hmm.
there was 3 and the 1, so I would take them,
Mm-hmm.
and I would find the biggest end value, which is when I have 2 elements is quite easy, just do the end. But if I have like this one, the whole array, I need to find the largest element, or at least all the candidates that could be the k, and maybe doing some some backtracking approach because I can't think of like the return statement. But yeah, basically I need to, my intuition would be to try all the swaps and remember the end values, and just following that path through I have a sorted array and remember the k and just keeping the max one at the end. Is that what I'm asking to do? Yeah, the maximum value. Yeah, okay. But that seems a bit, what are the constraints? Yeah, this to the 10 to the 5, that's not really feasible. I mean, because if I have 10 to the 5 array, which are reversed, that would be pretty big. So my second intuition would be like a greedy approach when I try always the maximum k that I find. But would that work actually? Wouldn't be much more efficient if I have a completely reversed array right now. Mm, 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 mm. So yeah, maybe yeah. Okay, my approach, if I can outline it, would be to find the candidates, like the end candidate. When I could name the end candidates, the end values up, and the swaps, and just try like greedy, just with the max value, like using a heap or priority queue.
Try
But
greedy.
and if
What do you mean by this chart? So find the and.
like
What do you mean by one here? Find the and values and their swap.
here we have like we can swap basically every element, because I mean like the 3 and the 2 are valid candidates, they are not in the right place. So basically here every element needs to be swapped. So I can either like swap the 3 here with the 0. I can swap the 3 and the 1, the 3 and the 2. And yeah, that's pretty inefficient strategy here. I would swap like firstly the 3 and the 2, and afterwards the 3 and the
Why
1.
would you need to swap the three and the two?
Um, to have a sort of sorted begin of a sorted array here. But yeah, now that you're saying it, I must do some other swaps after to fix that. Doesn't lead me so
Yeah, this
much.
it's not about getting it efficiently.
Um, mm, mm, mm. Let me think.
Like, we just need to
Can I
put the three in
use?
its spot.
Oh yeah, okay, yeah. I need to use that's it, a permutation of 1 to n minus 1. Yeah,
Mm-hmm.
okay. So the spots are predetermined. Okay. How can I leverage that? Mm, okay, so basically I have the 3 here that I know must be here, and the 0 must be here. But okay, so I swap them, and after that I have 2 and 1. But I know the spots also, so to swap them. Okay, so but doing that, I have k equals 0 for the first swap, and for the 2 and the 1, I have the end values is actually 1. Yep. No, no, it's 0. Okay, yeah, it works. Okay, I understand. Because it's 1 0 and 0 1. Okay, yeah. But does it works all the time? What would my strategy change? Oh no. I have the 3 here. Okay, let's suppose I swap those. 3 to 0 here, that's a 3, and here that's a 1. That costs me actually 1, so let's put it in parentheses here. But after that, the 1 isn't in the right place, so I need to swap it with a 0. Okay, maybe like a 2-pointer approach would work, and depending on if the result is both end of my 2-pointer approach are in the right spot, I move them or not. But how do I keep the k here? I'm having a hard time to find like how to link that with the maximum value of k.
Let me give a hint here. So pretend we. Let's look at this. These ones. How many people are out swapping? Let's look. 3210, right?
Yeah.
Everything is out of place here. 3210. So we know we need to put 3 in its spot. Who does 3 need to swap with? 3 need to swap with 0. So how is 3 gonna swap with 0? We need to find a k such that if we add 3 and 0, it equals k. But if you add 3 and 0, there's only one k, right? Which is pretty much 0.
Yeah. Yeah.
Right. So in order to get 3 in its spot, we need a k of 0. Right. We need to find a k that we need to find one exact k. Right? So for example, now we need to swap 2 and 1 to get 2 in its place. We need to swap 2 and 1 to get 2 in its place. What's the add of 2 and 1?
That's also 0, but that's convenient
2
here,
and 1,
right?
Is it? Oh yeah, it is in that case. It is convenient in that case.
Yeah, that's convenient, but yeah. So.
But pretend, yeah, it is 0.
Let's pretend it's 1.
It is 0 in this case, but also, yeah, because everything's out of place, but it is 0. Let me think of how I'm gonna give this advice. But yeah, I don't know. Just explore it for a second. Let me think of a better way to give it.
Yeah.
With a better case.
Can swap element that the array can be sorted in non-decreasing order using any numbers of such swap. If none in order sorted, then 0. So here's k equals 0. But if that would be 1, let's suppose. Like, I cannot swap. Okay.
Try this example.
Okay, so let's begin by the 4 here that needs to be here. Swap with 3. Okay, so we have to do like, let's take this path and just end those one. So that's like this one and basically 0 here.
Okay, I'll give a small, like, one hit because we're sort of running out of time. So
yeah,
we only care about elements who aren't in their place yet, right? At all, because if they're already in their place, we don't have to swap them. They're already in their place. So now we have all the elements that aren't in their place, and we need to get them into the right place. That's the problem we're at.
Yeah.
So in order to get them into the right place, we need to find a common k, so that if we add any of them together, they equal that same k.
Oh yeah. Okay. So okay, let's walk through this path here. So the 4 isn't in place. The 1 is good. The 2 is good. The 0 is not good, and the 3 is not good. Okay. So yeah, I think binary here would be helpful, and just okay. So maybe let's just, so in this example 0, 0, 1. Yeah, because we need to find a k that such those 2 here are swapping, and after that I need to swap the 3 and the 0, so I need to also swap those. So basically doing a AND operation between all those numbers, and yeah, maybe just ending all those numbers return that result, right? Let's look to the first example. That would be, yeah, because in fact all the numbers that aren't in place, I need to swap them. So doing an end operation. So at the end, I'm doing basically end over and over only those numbers.
Yeah.
Okay, so yeah, seems pretty good, but really simple with what I expected. Well, I imagined with my greedy approach and all that stuff.
Yeah.
Um,
So what's the strategy? What are you gonna do?
yeah, just looping once to the array, checking if the value corresponds to the index. If not, it's invalid. So just um, ending, maybe put that in some sort of list, or just doing the end operation to a variable, and at the end return the end of all the list I built, or the variable that I ended all the way through.
Yeah.
That would be O of n, so working with the 10 to the 5, I think. And yeah, okay.
Makes sense. Okay, go ahead and implement.
Yeah. What would be the max end? Let's call it max end. Max end in permutation. Just giving the permutation, that's a list of hint, and the k, which is the int, and returning a hint. Let's from typing input list. And yeah, we can do it like that.
Yo, chat.
And
This is
equals none.
this was a contest
That's really
question.
efficient, but we'll see later.
I was able to do
Just
it in the
looping it
contest, so I was like, let me
on
ask somebody this
I.
in an interview.
Just calling nuns
But it's kind of dumb actually.
in enumerate nuns, and to, and just if num is not in place, so basically if it's not the I not corresponding, so like invalid place here. If ends is none, I cannot think of a better way right now. Ends equals to num, else ends, and at the end just returning ends. Okay, but oh, it could be none actually. Okay, and let's handle that case. If ends is none, just return. I wanted to return. If it's not, return 0. Okay. Okay. Let's maybe do a dry one with where is it? This one,
Yeah.
first
Wait,
example.
let's look at the code real quick.
Yeah, so just keeping track of like that would be the k, not the
Yeah.
ends. Maybe just the k here. So here, and also here. Oops. Here. Okay, so just looping it through the list. Actually, if it's invalid place, we have its index, which are not its value, because we have a permutation from 0 to n minus 1.
Yeah.
And if it's actually my first number which is invalid, I'm just putting it to k, and otherwise I just ending to my already existing k. And at the end of this for loop, if I didn't find any invalid number, actually my k is none, so I'm returning 0.
It's like he cut out. Lagged. Give him a sec. Give him a sec. Give him a sec. Yeah, it's a hard one,
That's good.
honestly. Oh, sorry, you lagged. You lagged.
Yeah, my
Repeat
connection
that?
is I'm actually on mobile, so
Yeah.
it's
Oh,
yeah.
yeah. It makes sense. Okay, how do you think you did? How was that for you?
Yeah, the second question, without the hints that you gave me, I wouldn't have fired it,
Yeah.
because yeah, I kind of understood that I only need to take care about the numbers that weren't in place. but yeah, the end operation with all the candidates, yeah, couldn't think of that.
Yeah.
But
Does the
otherwise, on
does
the
the
first,
solution make sense?
yeah, actually, because we at the end we need to end all the values to put them in place. So yeah, I should have
Yeah.
think of
Cause
it.
it's kind of transitive. Like if you move one, like you need to be able to swap any of them in any direction, and it has to be one final value, right? The one final K.
Mm, yeah, yeah, I was struggling to understood like the maximum value. I was like, yeah, but if I only have one, if I have like a solution with k equals 1 and k equals 0, what do I choose? Because like my path is invalid.
Hmm. Yeah. Makes sense. Cool. Um, you're lagging out a bit, but I'll give the feedback and hopefully you can hear it on your side. Yeah, I think with question one was good. You're a little bit slow on it, and I think the reason you're slow on it, you were making good progress along the way, was good at dry running it, but some of your variable names where you're confusing yourself with some of the variable names. So I would just make sure to just have more descriptive variable names if it's gonna help you solve the problem better. Although like some of the it's okay. Some of the variable names are they're good, but initially when you first wrote it out, you had some variable names that confused you, and then you had to update them. So yeah,
Mm,
just be make sure that you have descriptive variable names. Sometimes like just doing X, Y, K, I, J will confuse you.
yeah,
Um,
yeah.
overall, no, you did good. Like able to solve it. Second question, yeah. Second question is a bit of a tricky question. I would just I think just working through the examples top to bottom, because usually the first two examples are going to be the example when they give you examples. The first two examples are going to be the ones that will give you the most advice, and then usually the third one is some weird edge case. So I think you're jumping to a third one right away, and that's that. I mean, that's not really good advice because maybe the examples are would could be in different order. But what I would just say is
Mm,
just try to work through the simplest example possible. You're working through example three, which is everything out of order. First example one and two is just one thing out of order. So just work on small examples and slowly build your way up to bigger examples. The main thing with these questions that are kind of hard is looking at the example and figuring out the patterns. So working through the examples. Um, and when I did this question, I did it during the contest. Yeah, I was working through the examples. I was visualizing what they would look like in binary, trying to add them and see. And then that's how you'll eventually come to the solution. Maybe not during the interview, but I think you took the hints well. You implemented the code perfectly correct. I don't see any issues with it. And yeah, you're able to take the hints well and implement something that works. So good job. This
yeah,
question's kind of
thanks.
dumb, can't
Thanks,
lie,
James.
but um, yeah, good job on
Yeah,
the first
pretty
question as well.
pretty hard. Yeah.
Cool. All right, have fun. Thanks for
Yeah,
tuning in
thanks.
or hopping on. All
Thanks,
right,
James.
see ya. Bye.
See ya.
Is this really the type of interview? I would actually cry if they asked me this in an interview. But I saw this on a. I'm running out of questions, man. I pretty much ask every question in the book these days. But he told me he did contests, so I had to ask him a contest question. Yo, Alpha, hop on. Yo, Alpha, what's up? You in?
Yeah, I think so. Hold on a second.
Your audio
Okay,
is a
you
little
hear me
low.
still?
Yeah. Can you say something? Just sound check.
Yeah, yeah.
All right, perfect. All right.
Okay.
Let me find your lead code profile for the intro. Your last interview, they're doing well on the channel. People like that one.
Oh yeah,
Let's see.
dude, gonna get stumped this time. You know.
No, I don't think so. Got a couple questions for you though.
All right. Do you have a coder pad?
You got you got a new mic, huh? That's what they're saying.
Yeah.
I saw you're back to posting videos.
Yeah.
Nice.
All right.
All right. Let me get the question out. How many legal questions have you solved again?
Like 1600 or something.
Holy crap.
Oh, someone knows me from poker. Who's the Josh Lee?
Hello and welcome.
Who's
Interesting.
This? My son. One versus one alpha in poker. Oh no, he probably seen you talk about it in the chat.
Oh,
Been here for a while.
because my Twitch name was 1v1 Alpha, so I don't know. Interesting.
Holy crap. Alright, you did a ton of questions.
Yeah, I haven't been doing as many lately. I've just been doing hard ones, like one a day or something.
Alright, I'm gonna start a video. Let me get the question ready.
All right.
Hey everyone. Wait, sound check. The audio is good, huh? Chat?
I think so.
Alright. Okay, I'm gonna set this up. Hey everyone, so today I have Alpha in who solved 1,652 leak code questions. How many is that of the platform?
Like close to
Literally
half.
almost half, but top 4,000, pretty much that's his exact rank here. Look at the streak; it's an insane streak.
Dude, my streak. I stopped my streak. It's over.
It's dead. That's crazy.
It's dead.
Oh yeah.
I was like, I'm not gonna maintain a streak. I think I had like 700.
That's wild. So, wow. So yeah, we have him on for a coding interview. He destroyed the last coding interview, but today I'm gonna ask him a very popular Google coding interview. I've asked this to a few candidates. No candidate has been able to solve it. Let's see if this candidate is going to be able to solve it today. So,
All right.
yeah. Holy crap, you did so much LeetCode questions.
Yeah.
1,000.
Got to do more real work.
I want to get to
instead of
1,000.
questions.
Then I'm good. But
Oh, get to 1,000. Let's see.
1,000 days badge. Okay. Let's get straight into it. So, all right, we have an interactive code editor. I want you to get working code. We're prioritizing working code.
All right.
And yeah, here's the question.
Okay.
So we're pretty much going to be given a list of files. It's a very popular Google interview question. All we need to do is print out the list of files into the console, something like this.
All right. So I will say I watched your stream a little yesterday where you gave some hints on this. So that might make it a lot easier for me.
What are you thinking?
Well, you mentioned something like my original idea was when I saw this really quickly yesterday. I mean, I didn't see the person code it or anything. I just like watched for like 5 minutes. But have some nested thing, some nested dictionary thing, and you basically said like a lot of people go with this nested dictionary thing and it becomes kind of difficult. So you suggested a tree, and I just thought, okay, well, how would a tree work in my head?
Mm-hmm.
And it actually makes perfect sense. And I will actually say that, I mean, it's been a while ago, and it was kind of similar. So I did do a Google text screen. It wasn't exactly this question, but it was very similar.
Mm-hmm.
So, something like, you know, you have nested stuff and you have like tabs and whatever. And I was able to do that one. And that was like actually for Google. So,
Mm-hmm.
but yeah, we can try the tree idea. is what
would
I'm
be your
thinking.
approach?
Yeah. So what I'm thinking, and yeah, I haven't like coded or anything, but oh yeah, let me switch this to actually. Can I switch this to Java as well, just so it'll be a little bit more difficult?
Sure.
All right.
I mean, I have a follow up, so if you want to tell.
Okay. No, it's all. I mean, I'm trying to practice Java, and
Okay.
I always do this thing where I'm like, well, if I do it in Python, it'll be easier. But
Yeah.
let's just stick to. You don't learn by doing the easy stuff. So
Yeah.
okay. Okay. How do I? Let's see. Paste it again. Can you paste it again in here?
Sure. Let's put it there.
All right. Yeah, it's fine if you have follow up. So basically, what we want to do is we want to. Yeah, I think just knowing like tree is better gives me a really good idea of what to do. So essentially, we want to have like a level of where we're at. So for example, this first thing, like we would basically parse all of these, and maybe it wouldn't be super easy, but we'll see. So we want to parse all of this. So like web app would be like level 1, and then for this first thing, and then assets would be like level 2, and this is like of the tree and so on. HTML level 3. And so you basically want to parse, and you can just split on the what's it called, the dash or whatever the thing's called, to get like an array of strings, and then you parse on that. And then thinking about it, what we want to do is we basically want to I think maybe this is kind of like a try almost, even trying to think of like what this would look like, because we want to print these things. Yeah, actually, even knowing it's a tree, I don't think it's that simple. So okay, so like for this first example, like we parse all these things, but then when we print this, can we print in any order? We can,
Yeah,
right?
this is one output and this is another output. I don't really care about the order.
Right. Okay, so now I'm getting it. So basically what we want to do is like we first want to parse it and put it all into the tree. And so we can have like top level root with just like nothing or whatever. And so it's kind of like a try, I guess. But yeah, we basically have like an n-ary tree, where every level will just have like a the level we're at and like the word we need to print. And then we can kind of just like traverse it. Like once we have can I do the drawing here somewhere? Drawing. So we'll have like this top level thing, and then we'll have like other nodes. So this will be like web app, and the web app will have like assets and stuff. So let's just say we have a little bit of stuff. So let's say we have web app. The web app has assets. It also has like index.html and so on and whatever. So we'll make this into a tree structure. We're gonna like put these things in. Yeah. So once we actually do have the tree, I think we can just do a DFS. So essentially, we can just go down and we say like, okay, we're at the web app. The web app is level 1. So let's print web app. And then we just need to have like the number of spaces equivalent to its level. So maybe for every level we put in like 2 spaces or 3 spaces or whatever. I don't know if you care about that much, or like a tab equivalent to how many what level it's at. So essentially we'll print web app. Then we'll go down to assets and we'll say like assets is on the lower level, so we'll need like more spaces. So we'll print assets. Then we'll recurse back up to the web app, and then we'll go to index.html, and that's going to be the same level as assets. So we'll print like index.html. So basically, once we have this tree structure, the problem's kind of solved. And then we can just like recursively go down in like a DFS and then do it. So the first step is take all of these and put it into a tree, an n-ary tree, because like every node can have infinite children, kind of like a try, I guess. And then and then just traverse down, go down every route, and just print stuff. Does that make sense?
Yep.
Okay. So I guess first thing we need is like to think of like our tree structure, like because it's not going to have like a left and a right, it can have infinite. So we'll have like a tree. And so what do we need to have in this tree? So we basically need to have a level.
Where are you? Okay, there.
Yeah, so we need to have a level. And then we need to have a list of trees or I guess we need one more thing. So we need string like word or whatever, like what are we actually printing? And then we need to have like a list of tree, which is like children here. And we don't know how many that's going to be. So this is what it looks like, I think. And then now we could insert things in. So we'll have a constructor that will be like public tree. And so what do we need? So we need to give it a level. We need to give it a word. And then we'll just say like this level equals level. This word equals word. And then children will be a array, just like empty. So I think that's fine. Oh, this is string. So we have that, and then we need to be able to like insert a word into here as well. So like public void insert, and then we'll just insert like a word in here. We'll see if we need anything else. And this is basically going to say, okay, tree or new tree equals new tree with level +1 and word. And then we'll say children add new tree. We might need more stuff, but this is essentially kind of what we need for the tree. And then we can just have a traversal. So the first thing is we need to take this thing and create the tree. And so I'm just going to make a root with a level of, let's see, what is your example? So it looks like in your example, this web app thing has like no spaces, right? And then assets has like 1, HTML is 2. Okay. So what we can do in that case is we want to make a topmost directory with just and can we assume like that we won't have like empty strings and things like that? Like these will all be valid in valid format.
Mm-hmm.
Okay.
Yeah.
So we can make
gonna have valid format, no trailing spaces, no like starting spaces.
So we need to make a root that's just going to be like the topmost thing, and we'll make that like level -1 or something. And then we need to, for all of these, we need to basically insert these into the root. Or we don't need to insert into the root. We need to insert them into like the next thing. So I'll figure out how that's going to go. But yeah, basically, so let's do that. So let's get rid of all of this. Static. So this will be called like parse files or something, or print files. And it'll be okay. And so it's going to take I guess just like a string array. Files. Okay. So we want to go through all of our files. And we want to turn it into an array by splitting. So let's see. String array parsed equals, forgot the syntax. I think it's like split, and then you can do this. Hopefully that's correct. Let's see. Split is not applicable. Oh, it's because it's this. So let's just print it just to make sure we're doing it correctly.
Okay.
And then let's go from there. So if we end up printing, what do we get? Oh, we never called it, right? So we have to call print files with this thing. Okay, so we can just copy that in. So just to make sure we're parsing correctly. Oops. All right. String. Okay, so let's see if we're parsing and stuff. Okay, so we have oh, I see. So we have this like initial directory that we want to get rid of. Yeah, basically. Or we could parse like this and just ignore the first guy. Either one's fine. Yeah, I guess we could do it. We could say this instead. We could say file and just use a substring. I think this is should take care of it as well. Okay, so now we have everything. And now basically we need to go through these and insert them in. And ideally, we want to also insert the child. That way we can, so maybe this will return like a tree. So we can do return new tree. So basically we insert it in, and then we keep going. So the other thing actually that I'm thinking for this tree that we need to do is like this child can already be in here is a problem.
Yeah.
So yeah, so basically we need to know if it is. So we can have another thing in here, I guess. So basically let's see how we do this. So we can have a map instead, I guess. So we can have a map of string to tree and like this, and then that way this is a
Is this class a tree node or
it's a
node
tree
node?
yeah, I mean it's a tree node, it's a tree is a tree node, basically it's like the same thing. Yeah,
Okay.
tree node. Yeah, so because a tree can be like one node, right, essentially. So
Yeah.
okay, so basically we need to say if
'Cause usually when I see people create like a tree class, usually they have like another node class, and the tree encapsulates nodes. But this
yeah, that makes sense. Yeah, I think this is just like all together, I guess. So if children contains key word, then we can just return that. Because we don't want to be inserting if it's already there. Even though that still might be fine, to be honest. Like even like if we put in duplicates, it actually might still work. But this is gonna be better. Okay, so basically we do this, we do children add or it's gonna be put word new tree, and then we return the new tree. So we're basically saying we have a map of the string and the tree, and then when we do an insert, this is like if it's already there, we can just return it. Okay, so now what we want to do is we want to make a root node as well, so we can do that as well. So we can say like tree root equals new tree. Level will make it -1. The word will be nothing, and then the children will be nothing. Okay, so we always want to start at the root whenever we do an insert. And then basically we want to say like, for each one of these, insert it into the root. And then give me back the inserted thing. And if it's already there, it'll just give you back the inserted thing. So I think we should just be able to say in here for string word and parsed. Okay, so we basically just want to say we want to have like a current thing where we're at, actually. So we could do that here. Tree cur equals root.
Mm-hmm.
So we want to say cur insert word. And this is going to give us back that inserted node. So tree result equals cur insert no word. Yeah. So once we have this, then essentially we get this back. Actually, I think we need to do, or actually, this needs to be cur. So essentially, we insert the word and then we update cur to be that. So now I believe we'll have the full tree. Like this will actually give you the entire thing, assuming our inserts are correct. So now all we have to do is just do a DFS on the root node.
Mm-hmm.
So we essentially have to go through all the keys, recurse down to all of them, and then, yeah, basically print them. And I think that will be fine. Let me just double check. So tree equals new. Yeah. Okay. So let's try to do something like that. So we need another one that's like public static void DFS. It's going to take a tree root or node or something. Okay. So what we want to do is we want to print. We basically want to have the number of tabs equal to the level, right? So if node level does not equal -1, because that one we don't want to print, then we want to print here. I don't remember how to tab like how to print a tab the level times. I mean, I guess we could do a for loop. I don't know if there's like a better way. I think that's probably fine. So we could just say like for int I equals 0, I is less than level.
You do like system print without the ln.
Yeah, I know, but we need it to be sorry, 1 second.
You do like
we need it to
T?
be
Like this? How many times? Could go like that times.
I don't think you could do it times. I don't think you could do that. So that's why I said you have to do a loop. And then we just do a regular system print. So we'll do like a new line here, I guess. We'll just say like system out print line. We'll just have like a new line here. Okay, so we basically just want to do the normal system print here. Print tab, I guess. It's like this, I think. So this will give us the tabs. Then we want to print the actual node. So then we could do, or actually I think if we do it this way and we get rid of this. So then we want to print the actual like whatever's in this thing, which is node word. And then we want to recurse to all the children essentially. So the children are just going to be in the values. So for tree val in node children values, we want to call DFS in all those. Okay. And then we just call DFS on the root. And I think that's it. So yeah, I can give this a try and see how we're doing, I guess. I feel like this one is like a little bit more complicated to code, less than like, I mean, the algorithm part's also kind of complicated, but yeah, there's like this I always struggle with the string ones. So did we print anything? No?
I don't think you built the, or you ran into DFS. Oh wait, print file.
Yeah, it looks like it just didn't do anything, right? I think. Okay. So maybe let's print the node level. And let's also, because I'm curious, like, what are we even getting? So let's print the node level. Let's print the node word. Okay, because I'm curious if we even recurs to anything. Okay, it looks like we keep getting -1. Interesting. So it said that everything we put in here was -1. For some reason.
Well, we should build the tree first, then DFS, right? Or
well, I did the insert, so that should build it.
But that just built it on one file?
Oh, that's right. Yeah, sorry. Okay, so I DFS in the wrong place. Yes, it needs to be outside. Okay, there we go. So let's see if that fixed it. Okay, so we still don't get anything, which is interesting. So let me just double check. So for string in file, like this file is correct. Root is cur. And then cur equals insert word cur. So let me just double check that these are correct. Okay, so the first one is printed correctly. And then yeah, for string word in parsed, cur equals cur insert word. And then DFS root. So let me just double check this section. So if children contains the word, then we just return it. Otherwise, we make a new tree with this tree's level +1 with the word. Then we put it in the children, and then we return it. Yeah, that part seems correct. It's kind of hard to like print the tree, because I think if I print the tree, it won't give you the right stuff. Let's see. What am I missing? Cur equals root. Yeah, we always want to start at the root. Cur equals cur insert word. And then we DFS root. So if node level, oh, wait. Oh no, yeah, if node level does not equal -1. Oh, I see the problem. So we want to not print if it's -1, but we still want to recurse. So what's going on, I think, is like we're just starting at the root and then we're just never recursing because it's always -1. Okay, so let's see if that fixed it. Okay, well, that's weird. Let me get rid of some of this. Let's also comment out some of this just to see like if it works correctly with one thing or not. Okay, so it says web app. How does it show web app twice? Assets, HTML. Let me print this as well, just to make sure this is correct. Also, where are we printing the number? It's kind of weird. Okay, so web app assets, HTML, a.html. Oh yeah, we also want to print like we also want to print out. Yeah, I think I screwed this up a little. So we want to print that like double dash thing, right, in the beginning or something. So, and then here, I think we want to print the word, and then we want to print a new line after. So I guess I can combine that here. I can say print this plus this. Let's see if that makes it any better. Okay, so we have it repeated for some reason.
Well, it might just be you just have too many system prints that some aren't useful. Like
that might be true. Oh yeah, that's right. Okay, yeah, that's right. Yeah. Okay. Okay, there we go. Was that correct for the first one? Web app assets, HTML. Okay, yeah, let's try the whole thing. So yeah, I was like thrown off. Okay, it is because I have too many system prints. Yeah, it's definitely hard to catch your own errors when you're doing it yourself, but when you're like seeing it, it's like, okay, I think this is correct now, right? Or like one of the valid formats.
Nice.
Okay.
Nice. All right, moving on to one more question.
Okay.
Yeah, it's a fun one. What do you think?
Yeah, I think I really struggle on these string ones. Also with this one, like this one really does kind of test if you can just make data structures on the fly. Like even though I knew it was a tree, it was like, how do I have all these things? How do I not have duplicates? You know? So I think the algorithmic complexity isn't that bad. But yeah, this was kind of similar to the Google stuff I had. And yeah, they had some, I think it was like they gave you a tree and then you have to print the nodes based on the level with tabs. So they already gave you a tree. So this one's a little bit harder because like you have to build the tree.
I see.
But yeah.
Yeah. Okay, let me look at the code. Yeah, the code looks clean. Like with the level, I think we don't even really need to track the level. We could just pass that as in like a value in the DFS.
Oh, like just pass down +1?
Or like when you're doing the DFS here, like have a level.
Yeah, that would be fine. And then not, yeah. So I think that would probably be better. So you have a level. You don't have the level in the actual tree itself. And then yeah, that would make sense as well. And then every time you go down, you just do +1. Yeah, that would work as well. That makes sense. I think that probably would be a bit cleaner as well.
Okay. Yeah. All right. Let's move on to the last question. If we finish early, then I'll just take a quick break before the next guy.
Okay.
So this is, I'm gonna post it up here. So this is the next question. We want to just add up 2 strings, but there's decimal numbers, 2 decimal numbers.
Mm-hmm. I see. So, okay, so a couple of questions. Can they be negative?
Yeah.
Okay. And
then
then like
just 2 positive numbers, sorry.
Okay, and then can they be like just way outside of, obviously you probably just can't convert to an integer or a decimal and just add.
You can't convert.
So we'd say they're like too big or something.
Exactly.
Okay. So I think in that case, what we need to do, and we said the result needs to be a string, I guess, because it's too big for an integer.
Exactly.
Right. And we can assume there's always a decimal.
No, it's like the decimal numbers, but some could be dot, some could be decimal, some could not be. Decimals could be huge.
Yeah. So what I'm saying is like, So okay, so we can have like
You can have 1
like
plus 2.5.
right. Can we have things like this, or can we always assume there's a 0 in the front?
We can get 0.5 too. But
Okay.
let's assume there's 0 in the front. Let's assume there's 0 in the front.
Okay. So I think the first thing to do that I'm thinking is just, yeah. Okay. So the thing I'm thinking is like, we need to, we can do it separately, I want to say, right? So we can like split the number into decimal and integer sections and add them. And yeah, I mean, that makes sense to me. So essentially we can split the number into integer and decimal sections and add them. For the decimals, we can also kind of normalize, I guess. So for example, if we have like this and we have like this, ideally we want them to be the same length. So I think with a decimal, you can just add zeros to whatever the end is to normalize them, and then you can just do a straightforward addition. And basically, we'll have a result, and we just need to check if we have a carryout at the end. And if we have a carryout, that means that we need to increment our number by 1. And then the numbers, you can just do a normal add as well. So kind of like split them into decimal and integer, add the decimals, add the integers, and then check in the decimal if I have a carryout. And if I do, then I need to, yeah, basically increment my number by 1. If not, just whatever the decimal is.
Increment which number? But okay, we have the decimal, right?
Yeah, so let's say this was like this, right? So we'd have a carryout here at the end, right? We would add, and then we'd have a carryout. We'd have like a 1. And this is the decimal section. So whatever our numbers were, you know, like 123 and whatever, after we do those, we need to add 1 here. I mean, we could do that at the start or add it at the end, but yeah. Essentially, we need to add 1 at the end because our decimal, like, rounded up, essentially, right? That's the only thing I'm thinking of decimals. Like, that's like the edge case, is if when you add the decimal parts, they can round up by 1 value.
Mm-hmm.
Alternatively, maybe we can just do, like, maybe it's even simpler. First, you normalize the numbers, then you just add them together, and then you just put the decimal back where it was. So, for example, in this, I don't know what would be easier to code, but let's say we have 2321. So first we normalize the numbers, so this is 0. So we could say like, okay, well, this 0, we can just put zeros in front. So this can be like 0, 0, 0, 0. Then the decimal part will be like this, and the decimal part here is like this. So we can just extend the decimal, and then they will always be like the same size. Mm-hmm. And then we can just kind of do a normal addition and just remember where the decimal needs to go. So we'll just do a normal addition, basically get rid of all this, and then just put the decimal back where it was at the end. So that would be one way, and then we never have to like, basically, yeah, we never have to worry about like one number being too big or any of that kind of stuff. I don't think we actually have to normalize the numerator. I think we just have to normalize the decimal section. So like if this is here, like this would be fine.
Okay, I like the first approach because we don't have to find where the decimal needs to go. But
okay, so just split it, add them together, and then add the numbers. I think that makes sense as well. Yeah. Okay, so let's go with that then. Can I code that then?
After we find the result, right, we do 1, 2, 3, and then pretend we had a carry on. Are we just gonna perform the same addition but with the 1, like same sort of addition but with the 1? Like take the result of this.
Oh yeah, actually, yeah. So our initial carry for the number part can just be whatever. Like if the decimal was a carry, so we'll have a carry number, right? Mm-hmm. So our carry can just be 1 if the decimal like went over, or so 1 if decimal went over, or 0 if not, and then that will basically handle it. So first we do the decimal, figure out if we have a carry, and then we do the number part, and then we just get both of those and we just add those together and then put the decimal between it.
Okay.
And that should be it. Yeah.
All right. Sounds good. For time, we have
so
7 minutes to code it.
We have 7 minutes to code it?
Yeah. Two questions in 20 minutes.
That's going to be tough. Okay. Yeah. We'll see. That goes. All right. Well, let's reuse what we have here. Get rid of this. All right, so I guess the first part is like we can take two strings and return. Yeah, so let's do that. So we take two strings and we return a number, and we take a carry. So that could be the first part. And I'm seeing if I can use that for both of them. So we take two strings, we return a number. Yeah, well, let's just whatever. So this will be like add or string, add string A, string B, and carry. Okay. So basically the result. So I think when we add them, we want to reverse them and then add them and then reverse the result. So let me see how I do a string reverse in Java. I forgot. Reverse. So string builder. Oh yeah, you could do a string builder result to string. Okay, so A equals string builder A reverse to string. Same for B.
You could just define without specifying the data type in Java. Or no?
Well, there's already a data type here.
Oh, okay, I see. I see.
So I think I need to import string builder or something. Or
Just
string builder.
Just reusing the same variable from the parameter.
Yeah. Let's see, is undefined for the type solution. Oh, I think I need new.
You can always talk to the AI right there.
Okay, yeah. Yeah, I guess that makes sense. So how do I... Okay, so I want to just reverse these. Okay, yeah, there we go. Stringer. Okay, so there's a reverse function.
Reverse.
Yeah, so new string builder reverse to string. Isn't that what I did? Yeah, that is. So the annoying thing here, sometimes it takes the compiler a while to get rid of the red, so I wasn't sure if it was right. Okay. So now we need to do the last part, which is like C or as string builder. Okay, so now we need to just go through all the characters. Yeah. 0 I is less than basically let's see, max A length, B length. Yeah, gonna be kind of impossible to do in 7 minutes, or we'll see. Okay,
No, we
so
can go over 'em.
okay, string builder. Okay, so we need to do the what's it called? Int total equals yeah, so we basically need to add them together. So we need to do, I think it's like integer parse int or something. So here, okay, so let's actually first get, I think we can actually get the character and turn it into an integer. So we'll say like a char or a int or something. So if this is beyond what a is, then this is going to be 0. Yeah, so this is like I is greater or equal to a length. If that's the case, then this will be 0. Otherwise, we need to do integer, or I think we can actually do, no, we can do s or a character at I minus that. I think that's fine. Okay, so that's the a character or the a integer. Same for the b. Okay. So basically we get the characters and then we need to like do the add and all that stuff. So int total equals okay, so we need to do the total and the carry. So the total is a int plus b int plus carry, and then we need to divide that by 10. That'll give us like that section. And then we need to do the carry.
Divided by 10.
Yeah. So in Java, that's a floor divide.
Hmm.
Actually, do we want to do? No. Yeah, you're right. We don't need to do. We want to do mod, right? We want the last digit. So that, and then the carry will be the divide by 10. So carry equals this. This. Okay. Then we need to add the total to the string builder. I think it can take an int. We think we want to convert it to a character, though. I don't know if it does. I guess we'll find out. Not entirely sure. So this might be problematic. Yeah, we'll just do this just in case. Total minus 0, or yeah, just in case. Or actually, yeah, it doesn't work because it's an integer. Okay, so I think this just works then, because you can just add an integer. Okay, so we do this. Then if we have a carry left over, then we want to add the carry as well. Okay, now we need to just, let's see. We need to just reverse it again and then do a toString again. So return res reverse toString. Okay, hopefully that's right. So this will basically add the two numbers for us. Now we need to do the decimal section. And so the decimal section, the first thing we need to do is we need to normalize the decimal. So if one is longer than the other, I mean, do we need to do that? Maybe we don't. Let's see. Or we could do a reverse as well for the decimal section. Yeah, I think maybe we can just do the same. So let me look at it. So if we have like 0.3433, let's say, and then I have like 0.10. So if I do a reverse as well, so this will be like 3343, and then 10 will be here. So that's not good because I need it to be lined up like this instead. Yeah. So in that case, I think I do need to normalize that. Yeah. So let me look up can I add x zeros to a string in Java at once? Kind of like the thing you were saying. Can I just, like, instead of doing a loop, string builder? Okay, looks like you just have to do a loop. Okay, fine. So string add decimals, string A, string B. Okay, so basically if A length is greater than B length, then we need to get the diff and basically just add zeros to the end of B and then do the reverse. Yeah. Okay, so basically we can say string builder and string builder, or with B, then we need to say for I0, I is less than A length minus B length. Yeah, this can definitely be like cleaned up, but it's fine. So cur add 0. Okay, and then just B equals cur to a string. Okay, now we need to do the same for the other one. So this is just a copy, and yeah, and you can probably make like helper functions and all that. So if A length is less than B length, then we need to do the opposite. So A, B, A, cur append 0. Okay, now they're the same length. Now we need to reverse them. So A equals string builder, A reverse toString, and same for B. Okay. All right. Now we need to do whoops. Now we basically need to do the I think, or I wonder if we can just call add now, because now our add is the exact same thing, right? So I think instead of doing all this, we can just call the add function, and then we can just check the length. And so basically, so I think the idea here is, like, let's say this was like 8 or whatever. If this gave you a carry, the result would be one thing longer than these, and then we can just check there. So I think we can reuse here. So we can say like int decimal total And we can reuse the function we already made, which is a b carry will be 0. Or this should be a string. Okay. And so here, we can just check if we have the carry. So int carry equals, so basically decimal total length is greater than
Is
a
there a way
length.
maybe we could just pass in some parameter to add, to maybe like do one where it adds it at the end or doesn't in the other way?
Oh, that's what I'm about to do. Yeah, I'm just calculating the carry, and then I'll just calculate, and then I'll just call carry and get the rest of it. Yeah.
I see.
So basically, yeah. So if this is true, if decimal total length is, then this is 1. Otherwise, it's 0. So I think this add decimals is actually going to be, thinking about it, like we might need to, like I think this is actually going to be our main function. It won't be like add decimals. It'll be what's it called? Like the whole thing, or maybe anyway, maybe not. Okay, so I think, yeah, so I think it's something like this. So now I think we can just write our like function that will split it correctly, and then we can clean this up a little bit, and then I think it'll work. So we can do public static string. So this would just be like add decimals or something, or what did I call that? Or add nums. Okay, so now this will be string A, string B. Yeah, this is kind of like definitely could be better. Okay, so the first thing we need to do, I guess maybe let's just focus on the case where they always have a decimal, and then if we have time, we'll do the other stuff. Does that work? Like we'll just always say they have a decimal, so we don't have to be like, if it doesn't have a decimal, may do this. If it does, we'll just say they always do.
Sure.
Okay, so string num1 or string array num1 equals a split on the dot, string array num2 b split on the dot. Okay, so now let's think what we have. So basically decimal 1 equals num1 the second part, decimal 2 equals num1 the second part, or num2. Yeah, and then string like maybe not the best. I guess we'll do this a or b. Okay, so this will be like a1 b2. Okay, so the numeric part will be string. Okay, so the numeric part will be a10 and the numeric part will be here, b2 0. Okay, so we have like all the parts now. We have the numerator for the first one, the denominator for the second one. So now I think we can call, we actually want to take this logic and move it outside. We want to do the normalizing in our main function, and then we just want to call add decimals, and then we can calculate the carry outside as well. Mm-hmm. So basically, we're just going to say, take this over here. Yeah, and we're going to say if decimal 1 is greater than decimal 2, then decimal 2. And then, yeah, and then this is just decimal 2. Okay, and then also the other way, if decimal 2 or 1 is less than decimal 2, then we'll do decimal 1. Okay, so now our decimals are normalized, and now we can calculate the result. In fact, we might not even need this at all. Yeah, because we're just calling our add function essentially now, right? So we're just saying string here, des total equals add des1, des2 with a carry of 0. Okay, so now this will give us, yeah, and I think that should be fine. Let's see why it's not saying. Can't make a static reference, so it needs to be static. Okay, so then we can calculate our carry. And then this is basically just decimal total is the same length as decimal 1. So if it is, then the carry is 0, otherwise it's 1. And now our string num total equals add. So this is like num1, num2 with carry. Okay, and then all we need to do is just do, so we just need to do return num total plus the decimal point plus decimal total. And we can test this with something in here. So we'll say print, what do we call this? Add nums. Okay. And then we can try it out on, I guess, this case. So this will be like string s1, string s2. Okay, s1, s2. Okay, so we can see if it works. There are probably going to be some errors, but let's see what happens. Okay, index out of 1 bounds for length 0, line 55. Okay, so we can print these two things. Let's see, a1 equals a split. Yeah, and then this is a1. Okay, let's print those. A1. And let's print A2 as well, or B2. Yeah, these names are also terrible. So, okay, let's see. Okay, so they're empty for some reason. Interesting. Why is that? We're splitting on the dot. We have a dot. Did I do something really dumb? Like, what am I missing here? Do you see any problems in here?
Let's see.
It seems like something really dumb, but
Print on the dot. Okay. Let's make sure we're even getting here.
yeah, I think we are. Yeah. Yeah, so for some reason it's not splitting on the dot.
We ask the AI. Maybe.
Yeah, that's fine. Okay, so if I do this, trying to split string on the dot, but getting empty arrays. Why is that? Okay, let's see. Issue you're having splitting on the dot because split in Java threats or use a split intervally. Oh, it's a regex. I see. Oh, so you need to do. Okay, interesting.
Interesting.
Yeah, I did not know that. Oh, I knew it was like some kind of regex thing, but yeah. Okay, so we're getting stuff now.
Yeah.
So did we get the right thing?
Let me just let me.
We did get an answer.
Like 5.5.
Oh yeah, we can try smaller. Yeah, that's a good idea. Okay. We can get rid of all these prints.
11.10.
Oh, it should be 11.0, right?
Yeah.
Okay, so the problem we have is, okay, so I see the problem. So the add, whenever we do the add, whenever we have the carry at the end, for the decimal, we shouldn't be adding it. We should be passing it on, right? So basically, like what's going on here is we're doing 5 plus 5. We're getting 0. And then we have a carry, and we're like, it's this line right here.
Yep.
So we basically just need to pass a Boolean flag if this is like a decimal or not. So we can say like decimal. And in this case, we can say it is. And in this case, we can say it's not. And so we only want to do this if it's not a decimal, because the carry should just go to the number. So if carry equals 1, and I mean, you can also like return the carry or something, but yeah, I guess this is like one way. So if it's not decimal, then we want to do this.
If we don't add the carry, would this work? This
Yes.
It's not going to increase the length increase.
Oh, you're right. Oh yeah, you're right. So actually, okay, so yeah, you're right. So what we want to do actually, if the length increases, we would just want to chop it off instead. Yeah, you're right. So basically, what we want to do instead is we want to say if yeah, so if the decimal total is bigger than the original, then we just want to chop it off. Total length is bigger than our original decimal, then we just want to chop off the front. So des total substring. Okay, there we go. All right. Okay, nice. Yeah, so the last part, I mean, obviously the variable names are pretty bad, and I can clean up to like have all these, if there is no decimal, then put in this thing instead.
Yeah.
But those are like small things. I can do that if you want, if we have time.
No, it's okay. Okay. How do you think you did? Like, how was that?
Yeah, I definitely will say if doing both of these problems, like I feel like this problem by itself should, especially in like Java or, I mean, honestly, whatever, takes a decent amount of time. I mean, maybe there was a way easier way, but I had a decent amount of reusability and it was still like kind of long.
Yeah.
So I feel like doing this problem, this is probably just going to be like a one problem, 35 minutes type of thing. So overall, I think I did okay. Definitely could have, like, this is definitely one that pushes, can you code really fast?
Yeah.
And I coded okay, but I could have coded faster. So that is something I can work on. And in general, I think one of my worst things, because I code in like so many languages, is built-ins and like string kind of stuff, because those are like really language specific.
Yeah.
So, but overall, I think the algorithm stuff is fine. And the first one, honestly, even though I got that tree hint, I still feel like it's kind of unique. Like LeetCode doesn't really prepare you. I mean, it does a little bit, but it's definitely kind of unique. I think both these were kind of unique. It wasn't just like, oh, I've seen this type of problem, so I had to kind of figure this stuff out on the fly. And I think it was like pretty good, but definitely a lot of places that I can improve in. So
I think the first question pretty good. Yeah, you fixed it up with the the level thing made sense. But yeah, you could also do the DFS without it. But yeah, no complaints on the first question. Pretty much the second question, you kind of already self-identified of just where you could have went faster was just understanding all of. I think with the string builder, you weren't used to the string builder, so it took you extra time to get the string builder like code working. As in,
I'm like pretty used to it, but not like advanced. And I definitely feel like if I knew more, I could do it faster. Yeah.
With like these edge cases to reduce the code, one thing you could also do is like just swap them if they're like if the length is here. Like one technique that I always see is just doing something like this. I don't know if this will work here, but let's see. Just swap these.
Oh, if like the first one needs to be bigger, you just like call it again on the reverse or something.
Or like instead of having these two if conditions, right?
Mm-hmm.
We just say if the length of this one is greater than the other.
Mm-hmm.
You just swap the variables. Because I don't think the variables do match.
I see. Yeah, that makes sense. And then the second case will handle the string builder part. Makes sense. You can't do that in Java. You have to have a temp, but yeah.
Okay, you can't do that.
I see what you're getting at. Yeah. So basically, you're saying like if one is bigger than 2, then swap, and then it's either 2 is bigger than 1 or they're the same, and then your second if statement can handle the zeros.
Like you only need one. You don't need to do the 2. You don't need to duplicate the code. Essentially.
Right.
Because you just swap like the smaller one, and then you only have to pad the.
Yeah, I felt like there was like a really big time crunch, so I definitely didn't optimize for like code quality. I was like, I don't have a lot of time. I need to get something working, and there's quite a lot to write. So yeah.
No, it makes sense. Yeah.
Where if I had like time, then I could definitely do it better. Yeah. Cool.
Yeah. All right. Got you, man. That was good. Those were fun questions. I need to. I want to keep looking on Interview.io and find like those good questions, like the one I asked you.
Yeah, I feel like this was on Interview.io as well.
This one, I just saw this randomly. I was looking through some questions I did in the past I feel like these ones really show language experience a lot more than like LeetCode, right? So yeah, these two aren't on LeetCode, so
yeah. Okay, cool.
All right, see ya, man.
All right, see ya.
Alright, chat, I'm gonna take a quick break. I'll be right back. It's so good.
Hello.
Hey there.
Hi, can you hear me okay?
Yeah, I can hear you.
Okay, great. How are you doing today?
I'm doing well. How are you?
Yeah, I'm pretty good. So I see here that you're an experienced candidate and you signed up for the standard coding interview. Is that correct?
Yeah, that's right.
Okay. Before we get started, if it's okay with you, I would just like to kind of know a little bit more about where you are in the interviewing process so I can cater this interview based on like what's best for you. So if you don't mind me asking, are you currently interviewing anywhere or planning to interview soon?
Yeah, so currently I am interviewing with a couple of places. I am within like mid or towards the end of um, the interview process. I have final interview in about 2 weeks um, with Amazon. That's the first one I can think of. And then
Figure out
well, like
given to singly linked.
yeah,
So yeah, cool. And and what level are you interviewing for?
SD2, I think it's L5.
Okay, cool. That's good to know. All right, we can get started now. Is Python a good option,
Yeah,
or do you want to? Okay,
yeah, let's do Python.
awesome. All right, I'm just going to put in the first question here. So the gist of this question is on line 19. Basically, you're given two singly linked lists, and you want to figure out if they merge at any point, and if they do, then you want to return the node that they merge at, and if they don't, then you can just return none.
Okay. Um, yeah, that makes sense. Is I guess before jumping into the question, um, it's guaranteed to have is it guaranteed to have just good inputs? Meaning,
Yeah, I mean, it will be singly linked lists. You should expect to see that, or maybe like none values.
mhm. Okay, that makes sense. And then we return the node with the value if it merges. Otherwise, we return a string none. Um,
Right.
Okay. Yeah, I think at a high level, just my thought process so far is at a first approach, I would uh, essentially, we iterate through both the lists um, and so like give an example, right? We have 1, 2, 3, and 4, um, and 5 and 6. Essentially go from left to right. So like while add that next or node that next, keep going. And then some way we want to store the value, right? Is because we need to keep track of what values we previously encountered. And then same on the second list when we iterate through that. For example, this same example, what, 7, 8, and 4, right? So we know that 4 is or is in within the whatever collection we used to save the previous values for list 1. Then it's safe to assume that this is where the list will intersect. So essentially, I think we can even store it in like a map um, with the um, key as the value, or I guess yeah, key as the value, and then the node itself.
Okay, yeah, that makes sense to me. What if you end up having like, duplicates? So like this node is different than this node, and it's actually these two nodes that are similar.
Okay, if there is duplicates, so wouldn't the first four we encountered on list two, is that where we would do the insertion, or like not insertion, is where the intersection exists?
No, it's the next four.
Oh, I see. Because I see. Okay, the last node reference, or last node, I guess.
I mean, not necessarily. Like, it's just because the list after this four is the same. Like, essentially. So it could also just be like this instead.
Mm-hmm.
In which case, and it could be either they merge at the second node or they merge at the first node.
Okay, got it. Okay, so in this particular example, right, it would be the last three values of list one and the last three values of list two would be a valid. So the last four essentially for both is where we want to say, you know, it intersects and becomes a single shared list.
I think the question is, how do you know where it intersects besides comparing by value?
Got it. Okay. Um, okay, I think where is list double merge point? So we essentially want to look for the merge point node that value is the output. Is that understanding correct?
Can you repeat that?
Yeah, we essentially want to look at merge the node that it's merging on, potentially its value, right? That's the output.
No, we want to return the node that it merges at. If you look at the types on line 32,
42. Oh, okay.
32, sorry.
32. Okay. Return the node. Oh, sorry. Yeah. Okay. Yes, I see that. Okay. So I think in that case, what we want to do is, um, I think we can move together on both nodes in terms of, or lists in terms of the iteration. So what I would do is, let's say I start with this same example, right? I would start with 1 and 7, and I see that the values are not the same. So then I move both of them to 2 and 8. And then, I see that 2 and 8 are not the same. Then we go to 3 and 4. Um, and then what we do is we see 4 and 4 is same. Uh, so this is a good candidate for intersection, but with the chances of having a duplicate, uh, what we can do is while 4 and 4 is same, and if 4 dot next that value is also 4, then keep going to the right, right? Essentially, the condition of the sameness has matched. We expand our window to the right, and the last element in that window which would be the last 4 here, we look at it that way, then we can return the node where, essentially the having went all the way to the right, and we can see 4.next is not equal to current dot value. We know that's the last one in the duplicate occurrence. So even if there's a third 4, it would work. So then we can return node dot value at the end, is what I'm thinking so far.
What if they're not aligned the way you're expecting them to be aligned? Like, what if it's like this, and say they merge at 5, not even 4?
I'm sorry, what is it? Oh, I see. So the list 2 is starting with 4, 4, 5, 6.
Yeah, and the actual merge point is 5.
And the actual merge point is 5. Okay. Yeah, that would be tricky because we don't have one-to-one kind of mapping now. So in that case,
What's going on here? Why are they struggling with this one?
okay, yeah, I see.
You're given 2 singly linked lists. Okay. So this is just like a fast and slow pointer solution. Let me show it. We're gonna be given 2 lists, right? 1, 2, 3, 4, 4, 5, 6. Right. And they're saying it merges at some point. How do I flip this? Let's say there's another linked list that goes like this. Points here. 5, 6. I think what... Oh, okay, I see. We just need to see if they merge at some point. I think we could put a fast one pointer here and one pointer here. Move this one up. 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 Right? And then like when this one reaches the end, put it at the front of this other linked list. So like move this one up. 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 Now, since this one's at the end, move it in front of this linked list. Move this one up. Move this one up. So now they're both at the same... Oh, that's a pretty good question. So I think what you need to do is have them traverse. You just need to find the intersection of the 2 linked lists. And the way to do that is like when you reach to the end of one, you put it to the start of the other one. Chat, does that make sense? Yeah, because that, like how you could think about it is because they might be in different sizes. You just want to traverse, you just want to get them so that they're the same distance. Or like you want them to traverse like the same number of nodes. So they could eventually meet. That's like the intuition. No, this question's not in my list. Raz, I'm about to join right now. Yo, Raza, what's up?
Hey,
How's it going?
can you hear me?
Yeah, I can hear you.
Uh, Sorry. Should I turn on the camera or does
No,
it
it's fine. It's
matter?
fine. It doesn't really matter.
Okay.
In the interview there.
Yeah, I'll just turn it on. It's fine.
What's up?
I don't look really good.
Yeah, it's not. It's no problem. You're not really showing on the thing. But what's it
Okay.
called? Did you get this question on the stream? This one, the
Um,
find the merge point.
no, I could not think of the solution, but yeah, it's pretty clever. And it's like if you see the idea for the first time, there's no way you could come up with that solution.
Like what? When you put the 2 pointers and then.
Yeah, just start over again at the same. It's pretty tricky.
Yeah. Okay, wait. Let me quickly look at this guy's Oh, somebody. Yeah, maybe it's in my list somewhere. Hold up. Some guy. I just need to look at one quick person's resume. Should take like
Mhm.
10 minutes. Then we'll go. Yeah, we got time. All right. Aziz, this is your resume. So, okay, I like the formatting. The format looks good. Let me move myself out the way. I mean, this is just classic tech resume format. Skills and stuff. Skills, I would throw the skills to the bottom. That's the first thing. Because skills don't really tell you that much. It's just pretty much a list of like all the languages you know, but that's more for the ATS. Like I would never look at someone's skills and just be like, oh, they know Python. They know C++. I would kind of infer that by reading the bullet points. So I would read the bullet points that you've done and be able to know, oh, you know Python because you did this project. So I would throw the skills at the bottom. I would have my experience first. I would put experience, education. Wait, when did you graduate? Some of the sizing is off too. Like some things are bigger font than others. So out those skills at the bottom. Oh, you're still haven't graduated. So if you still haven't graduated, if you're a student, you should put your well, you already have experience, education, projects, and then your skills at the bottom because skills is pretty much just for ATS. Does that make sense? Okay, let's look at some of your experience. I would fix the fonts. Ensure everything is similar size, like consistent sizing. There's some weird like bolding and not bolding and using like italicizing. Designed and developed a full stack web application using Flask to manage customer services, expenses, and revenue. Centralized client. Yeah, like I don't know if I would bold this. Usually I only bold metrics. So centralized client and financial operations into single. Like you wanna bold the things that you want people to look at, like metrics, maybe the languages, but usually it's metrics. You're sort of bolding like the adjectives here, which doesn't make too much sense. Design and develop the full stack application using, centralized client and financial operations into a single platform, significantly improving task efficiency and data accuracy. I would add a metric here, like pull up a metric for this. Replace manual workflows with automated processes, reducing service tracking time by over 70%. Delivered a responsive, intuitive user interface. Enhance the company's revenue potential by accelerating service management and streamlining. Okay. I think the bullet points could be a lot stronger. Like they're not really popping out at me. And I think first off by adding metrics and just spend some time on the bullet points, making them more captivating. And you could use ChatGPT for that if you want. Develop the centralized authentication system using .NET, enabling secure user role management across multiple applications. I like that one. Developed and integrated JWT-based authentication with a role-based access control, supporting dynamic redirection, multi-app session handling. I like that one too. Designed and deployed RESTful APIs for user role and application management using Entity Framework Core. Would anyone know what that is? Outside of that company you're working at? Like the first three are all kind of the same. Built a responsive Angular admin dashboard with secure routing, real-time data binding, and seamless API communication. Delivered a modular login application integrated with a test client app to validate cross-app. What I think you need to do is throw all your bullet points into ChatGPT to just improve the vocabulary or the grammar, and try to make them more captivating and add metrics to them. They should, like, here, let me send you a video of somebody who had a good resume. So what I would do is try to put all your bullet points to ChatGPT to just make them more captivating and add metrics to them. They should be a lot more results oriented. Like right now they're just kind of saying what you did but doesn't say the results. So by results oriented, you'd be like achieved X by doing Y. There's a, like I always send like this Google one. Google. I sent this every time to the candidates. Okay, related coursework, good. Okay, you have the expected graduation, which is good. Okay, you have good GitHub links. So I sent you the link for Google how to create a good resume. Follow all the advice there and make sure your bullet points are formatted the way that Google recommends there, and pass all these bullet points to ChatGPT to just make them better. Like with these ones it's a bit better. But yeah, cool. All right, Raza, you ready?
Sure.
I'm gonna send you over the link.
Yeah, I might struggle a little bit. I just
Yeah.
got an interview, so that's why I'm getting back into lead code. But I haven't done lead code in a while.
Awesome. Okay. Yeah, I'm gonna start a video. 1 second. Let me send you the link so you can get access.
Okay. Got it.
Aziz, like your resume, based on what I saw, I would say it's a 5 out of 10. But that's not because you don't have good experience. I think you just have it badly formatted, and you could make more captivating bullet points and just have better metrics. Like the experience is there. It's just putting it all into a polished product is what you're missing. Like you've done projects and stuff. You have the experience. It's just all those things that I mentioned. Okay, send over your resume over here, and I'll do them later after my coding interviews here. Oh, Z's, like one thing is, what's the business impact of all of the? What's the business impact of your bullet points? Like, why did you have to implement like a role-based access control? Was it so that you could launch with a big customer and gain some revenue? Because usually there's like some business goal. Maybe it was like a security audit that you had to solve. So I would tie it back to business goals. That's what I'm saying, results oriented. All right. Holy. Hey everyone, so today we have somebody joining in from Atlanta who's actually a senior software engineer, but has only done
Yes.
50 lead code questions, so probably a lot pretty rusty with the lead code, huh?
Yeah, I'm trying to get back into it.
So you did lead code in the past?
Yeah, when I graduated, as a new grad, I got some
Mm-hmm.
interviews and was practicing, but then as you know, last few years I haven't done much practice.
Yeah. So how
But
long
I'm trying to
did?
get back.
Yeah. Go ahead.
I might have done like 10, 15 questions in the last week or so.
I see. How long ago did you graduate?
6 years ago.
Wow, nice. So you recently just got promoted? Congratulations.
Yeah, yeah, thanks. But it's, you know, like at my company, it doesn't really matter. They just give you more work and,
Yeah.
and they don't increase my pay.
Wow, that sucks. I hate when companies do that. Otherwise, if a company's not gonna give you more pay, then I'm usually don't like getting
Yeah.
promoted.
So like I'm just trying to use the promotion, use my experience to like get out, get
Yeah.
into another company.
So how'd you get
Uh,
the promotions? What did you have to do? Was it like take on some big projects, like
yeah,
refactor? Yeah.
it did some features which were really useful for the customers, for the company, and yeah, so like that was pretty easy for my boss to convince like his manager. Like I just asked, can I get promoted? And he said,
Yeah.
okay.
Were
So
you like were you trying to get promotions a lot? Like, did you tell
no,
you?
not
Oh,
really. No, I was happy because I had a good work-life balance, and then in the last 2 years, the company just like they just started giving us more work. They started doing some layoffs also, so it's not like a great environment now. So
yeah.
that's why
I
I
see.
just want to like maybe I'll change the work-life balance
Yeah.
more towards work and get
So
into a better.
when it comes to practicing lead code, what sort of companies are you aiming for? So that I could tailor the question.
Yeah, actually, I have an interview with Meta. I don't know how I
Nice.
got it, but I got an interview with Meta,
Okay.
so that's why I'm really focusing these days.
Yeah. How far is it?
I have a final round in like first week of September.
Okay, so you already passed the technical phone screen?
Yeah, I passed it, even though I don't know how I passed it, but I did really bad on the first question, the easy question, and then I did well on the medium
Uh-huh.
question, and it
Okay.
passed me. I don't know.
All right. Is there okay, let me
But they said the recruiter said I was borderline. Like he said, like most people get rejected if they get this score.
He's
So
like, yeah, they probably took a chance. Like he has some good experience, which yeah. So now you know it's not just black and white. It's just
no,
pass
I
or
don't think
fail.
so.
There's
I
yeah,
think if you just like if you do time complexity well, and you know, like I didn't get the idea of how to do this question, but I did recognize the problem correctly. Yeah, you know,
hmm
like I think that's also important, and communication is also important, and taking hints from the interviewer,
yeah, makes
all those
sense.
things.
Okay, all right. Let me come up with a good question. Give me a sec. One sec. I think I have a good one.
Yeah, I also have to do system design
Yeah.
because for E5 level E5, like system design matters a lot. So, but
Okay. All right. I think I got a good one. All right. This is the. What programming language do you want to use? Python?
yeah, Python's fine. Yeah.
So we're given a list of unordered paths. We need to remove the redundant paths and any duplicates.
Okay. So the input might be A1 X. Given a list of unordered paths, remove redundant paths and any duplicates. Since it's a root directory of all subdirectories. Okay. Yeah, this looks similar to the one you were trying on the stream yesterday.
Okay,
With
well, actually, let me switch it up. This question is, I don't like this question.
Yeah.
All right, this is the real question.
In a binary matrix, find a path from top left to bottom right. Okay. So
yeah, let's just work through some examples.
Mhm.
Oh yeah, you draft up the examples and confirm like if that's a valid example, valid input and output.
yeah, okay. So let's say a binary matrix. So let's say so binary matrix, does that have to be like a square, like n by n, or no?
No.
Okay. So find a path from the top left to bottom right. So if let's say we have a matrix like this, then I'm assuming there's like no path because let's say we can only walk on paths that are labeled 1.
Yeah.
Then if because the bottom right is 0, like maybe that means there's no path. That's from what I understood. And let's say if it's wait, how do you represent matrices? Okay, so if you have like this, then we start at this place 0 0, and then we go down, and then we turn right. And I don't know how we return that. Maybe we can return that as maybe you can return it like 0 0. You start at 0 0, and then we go.
Let's say one or equals wall. 0
1 equals wall.
equals empty.
0 equals empty. Okay, so empty. Okay, then it's the opposite. So let's say, and we are allowed to make moves like we can go to the bottom or to the right, or can we go diagonally?
You can only go up, down, left, or right.
Up, down, left, right. Okay. And then again, how do we return the path
You can just have a
should we?
tuples of like the indices that we've visited.
Okay. So a list of tuples, or yeah, right. So let's say for the first example, we go to 1 0 or 1 1, and let's say there are no there's like no. If there are no walls, then we can take any path. We can go zeros. We can start at 0 0. We can go 1 0 and then 1 1. And this one, let's change it a little bit. Then it can be 0 0. It can be 1 0. We have to go 0 1, and then we can go to 1 1. And then it could be n by n, so we could also have a lot bigger 0 0 maybe, and then 1, and then 1. Okay, maybe like this. So over here we go. The optimal path is 0 0 0 1 1 1, and then 2 1 and 2 2. That's my understanding.
Yep.
Okay, so it's pretty easy. If you look at the like visually, it's pretty easy to find a path, but we have to come up with an algorithm to solve it. And one of the things we could do is we could try all the different directions for every. So we have to go from 0 0 to n by n.
Mhm.
So we keep increasing. We keep increasing the left and right until we get to n by n. Like we keep maybe increasing the x coordinate by 1, y coordinate by 1, each move like that, and then just do like a greedy search like that until we hit a wall. If we hit a wall, we don't proceed that path. We go back. Yeah, let's think about it. So we start at 0 0. We have two ways. We can go either to 1 0 or we can go to 0 1. And then if we go to 1 0, we hit a wall, so we can't go. So we'll return back to all the possibilities were 0 1 and 1 0, and now we only have 0 1. So I'm thinking this reminds me of having like a queue, maybe having a data structure like that where you have all the possible paths, and then you take out one of them and say, "Oh, this is not good." So you're at 0 1. From there, you can even go back. I don't know why would you do that, but that's also a possibility. So if you look at all the possible ones, I don't know if we should ever think about going back.
Think about going back.
Like if we just end up from 0 0 to 0 1, and then we keep going back to 0 0, we might get stuck in an infinite loop like that. So for now, I'll just not consider the possibility of going back.
Let's see. What if there's a 1 right here? So pretend you go this path and you get stuck. You can actually get it right. Get to the right.
Oh, okay. Yeah, that makes sense. So we go 0 1 1 0 0 1 and then 1 1, and then we're stuck. We can't go back. We have to go back. Or we can, yeah. I mean, we still have this path, so we can like say, hey, we've already been over here, so we don't need to consider this one because there's a shorter one from here. Maybe I don't know what I'm saying. Okay. Anyways, yeah. So what I'm thinking, let's just write preferred comments. We put like in a maybe like a DQ. We put like a put the index the starting index 0, 0. We don't stop until until the queue is empty. And every time inside the queue, we what do? We add all the paths, add all the possible paths, and add all the possible paths. And once, or it's a little bit confusing. Once we are done with adding all the possible paths, we could add it into a visited set. This part I'm not so sure about, but I'm thinking like once we have all the paths and we have exhausted the list and make sure it's not the rightmost index, then we could we don't need to, yeah, okay. I don't know if this is correct, still not sure. But yeah, add all the possible paths. Before we even do that, make sure check if it's bottom right. If it's bottom right, we can just exit. We don't need to. We found a path. But we also need to create like a possible, like we're not just returning if it's possible or not. We have to find a path. So
Yeah, exactly.
that part.
We need to return the path as a list of tuples.
Yeah. So every time we I'm thinking like maybe a recursive approach might be better, but I don't know why. So we will be constructing like a path for every different possible possibilities. So I was just thinking like maybe we should just do DFS on every one of them and just go to the right, go to the bottom, and in the DFS we could like whenever we come back from the DFS, we could we'd remove it. We could remove it from the current path. Does that help? I don't know. Okay. Yeah.
So let me get an understanding. Like, okay, we just want to get from the top left to the bottom right. What are the different ways that we can get to the top left and bottom right, like algorithm wise?
Like we can algorithm wise, what are different ways?
Yeah, what are the different algorithms for like getting from the top left to bottom right? Like you mentioned, Beffer search using the queue.
Mm-hmm.
We don't need the shortest, by the way. We just need any path.
Yeah. So yeah, Referrals search where we just go. We try all the directions. And then we have a list of directions like 0, 0. We don't have to do 0, 0. Like we can try the right, go down or turn right, go down and turn right, and keep building the path as we go. And the other I'm thinking right now is that we just we do the same DFS, but like it's the same problem. We have from 0, 0. It's the same problem from 0, 1 to 1, 1. It's so we could if we make sure we don't go up or left, then we could do a DFS also. We don't want to, if we don't go in the opposite direction, then we could probably do a DFS. I don't know. Maybe.
Okay, we have
Okay.
DFS, we have a BFS. Like, which approach do you think we should go with here?
I'm not sure.
Because if shortest path, I mean, yeah, like we're not looking for shortest path, so I guess we can go with
Mhm.
any. But
Yeah,
yeah,
I think so. I don't know, but I just started a breakfast search, so I'll start with breakfast search. I was probably just practicing a question in breakfast search. That's why.
is the part that you're having trouble with figuring out right now is how to actually return this path?
Yeah, just a path.
Yeah.
Because the issue is like in BFS, how do we collect the path for every whenever we take it, whenever we get anything from the queue, whenever we pop from the queue, how do we know where we came from? Does that make sense? Whereas in DFS, it might be easier to know where we came from. But I'm just struggling. Not sure. Okay, I'll just give it an attempt. I don't know if I'll get it or not.
Sure.
Okay.
Yeah. Go ahead and try it, and if there's any issues, we'll just iterate from there.
Okay, I'll just start with the just create a function. Find possible paths, and there's no class over here, so we'll just do. And matrices are represented as arrays of arrays. So it's just a list of lists. And then the number of rows, we go to the length of array. And the number of columns is just like the length of, let's say, row 0 or AR of 0. And then I was thinking maybe I'll just do like a BFS and see how it goes. Import BQ. And what do? So we have 0, 0 as our inside our DQ, inside the list. And so I'll just create one thing is the path, and the other thing is the I have the path. The other thing is like a listed set. Maybe I need it, maybe I don't know. And then how do we put? So we just put 0, 0 into our DQ. Oh, you can't do it like that. What am I doing? Okay, Q is equal to let's say 0, 0. I think it's like that, right? Don't know. And then while Q is Q exists, what do? We pop it. Also, one thing that is really useful in these questions is like a direction set, a list of directions. So we have 1, 0 and 0, 1 so far. I don't really want to go back. Maybe I do. I'll keep it 0, -1, and then -1, 0. And we can't go diagonally.
Sure.
So when we pop it from the queue, we get the current element. And this is a tuple. We can just do X and Y. I think that should maybe work. Or maybe car X and car Y. Okay. And now we need to go in all the directions,
Mm-hmm.
and we need to make sure we don't get out of the grid, get out of the matrix. So I need to add each of these elements to car. Is that syntactically correct, or is that wrong? Or
Where? Sorry, where? Here, Papa?
the while queue part, is there a problem over here?
No, no, no. I'm just looking around. I'm just.
Okay.
You're good.
Okay, that's fine. Okay, so we have current X, current Y, and what do? We add it, and we go on all the directions for I in directions. We create a new one, let's say, it's equal to better name. There is not good. Yeah, D is fine. For X plus B of 0, for Y, B of 1, and we need to make sure that they're all in so new X is greater than 0 and new X is less than, let's say, the length. We already have number of rows. And new Y is greater than 0 and it's less than the number of, it could be greater and equal to 0. There's no reason why I have this. And Y is less than or equal to number of bombs. So this condition, only if this condition is true, then we add it to our set of directions, to like the new, we add it to the queue, like we append it. It doesn't
So
really
if it's
tell
within
me.
bounds, we add it into the queue. Okay.
Yeah, if it's if the new one, if we check all the directions, if it's within bounds, we add it to our queue.
Okay.
We create a new tuple. And I also have a visited, so I'll maybe make sure it's not in visited. But I don't know where to use it, but let's just say, okay, let's just say this one is not in visited. So it's just like you've seen like a bunch of problems. So it's like I'm just using those ideas, but I don't know if I'm doing it correctly for this problem or not.
Yeah.
Okay, so once I pop it left and I go over all its directions, then maybe at the end I could add it to the visited set, this one maybe. I'm creating a tuple again and again. I don't know if there's a better way of doing it. Okay, so okay, now okay, if I start at 0, 0, I'm gonna try to understand it by just going through a little bit of examples and see what the state of the queue is. So at the start, the queue is just 0, 0. So we pop it, we make it empty. And then the cur is just like, okay, have another element cur to 0, 0. We go in all the directions. So we have, and assuming this is done correctly, d0 plus c1. We go in all the directions. We like the list of the new elements could be represent this. Okay, so we do all of these. We add all of them. So it could either be 1, 0. They could either be 0, 1. They could be 0 minus 1. So it's the same as the directions.
Okay, it makes sense there. Could we talk a bit about the path? So what do we return at the end? We just return path?
Oh yeah, we have to build the path as we go along. I added to the visited elements. Maybe the path comes yeah. So for now, I'll just add it over here. Same tuple. And then maybe we'll go over this and see if there's any issue. Okay, so over here, the queue is just null. And I check these conditions, and let's say they're all correct, then I add only these elements to the queue, 1, 0, and 0, 1. And I'll just comment this out. This is empty now. Okay, so we come here, we add 1, 0, and 0, 1 to the queue. And then later on, I just append this to the path. So the path is equal to 0, 0. And the visited set is equal to also 0, 0. So it's just this is a tuple, but that's fine. Okay, and then we go to 1, 0. So we pop this left, 1, 0. And we go in all the directions. So this is 1, 0, and we go in all the directions. Part I'm trying to understand.
So right now, what part are you dry running? What part are you trying to understand? Like if your BFS is working correctly?
Yeah, if it's building I'm trying to make sure the path is not getting created with like there must be somewhere I have to remove it, because if it gets stuck somewhere, then
Yeah, exactly. Like there's gonna be some paths in your path there that it went the wrong direction. It has to sort of backtrack, but we don't want those extra paths that lead to nowhere inside of a result.
yeah. I'm just trying to see how where that kind of issues happen. So maybe like in this example, we have 0, 0, 0, 1. We go to 1, 1. And over here, everything's my path will be like 0, 0, 0, 1, 1, 1. But it's not a good option. Like it's this one doesn't work. So how do I remove it from the path if it doesn't work? I have to go back and delete all the previous elements. Like it's like yes, 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 yes. Yeah, that part I'm confused about. We come here. Yeah, in the queue, we already lost like some data like about the right path. Like maybe the path. mm, Okay, so over here, how do I know? How do I even know? Uh, So I'm just thinking, is it even possible to do this question in DFS, or should I have gone with DFS at the start?
It's possible with BFS, but it's probably complicated. If we move to a DFS, how would that work? How would you build a path with a DFS?
Um, yeah, I would again I would use a visited set. And if if I come here and I see, oh, there's no possibilities, like we have to go back to one of the visit set. We could like in a recursive way, we could remove this from the path. When we recurse over here and we
Right.
see
Okay.
like when we are over here and then we recurse, we will recurse on both this on the right and on the bottom. When we recurse on the bottom and we see that this one has no possibilities, it returns something false. We actually in DFS, uh, we can I try it in DFS, or is there enough time for that? Or
Yeah, we could try it out. You have a little bit of time. But
okay,
like, how would you modify your DFS here? You're gonna do recursively. You're gonna do it iteratively here.
yeah. I mean, it's like I don't know the pattern really well for backtracking, but it's like you do DFS. Let's say DFS on the right, and then you also do DFS on the bottom. So we have to do two DFS, like you have to do both on the bottom and on the right, and like one of them will lead to the right result. And once we do that, we can just get back to the parent, or uh, but if it leads to the wrong result, then I don't know what we do. Sorry, not sure.
Yeah.
I'll have to study this.
Yeah. Okay, we're pretty much at time for
Yeah.
the question. But yeah, how do you think you did?
Not that great, but I'm just using like some of the ideas I found from other
Yeah.
problems and just coding them, like, but it probably didn't apply over here.
Yeah.
Um,
Okay. So let me think. Where could I give feedback here? I think you did a good job at the start of just making sure that you understand what the problem statement is asking and clarifying against some examples to just ensure that, yeah, the expected input and the expected output. So you built out all these examples, clarified that the walls are ones, empties, and zero. Um, yeah. So I think you just, yeah, just familiarize yourself with backtracking. Make sure you're
mhm.
familiar with that. Because yeah, I think that's the way I would do it, is using, because we just need to find a path from the top left to the bottom right. So with backtracking, we build the path up, and if we go one way that leads to a dead end, we start backtracking. So we start popping out from the path. So eventually, when we get to the bottom right, like that path variable is gonna have the result. You could do it with a BFS, and somebody in the chat was showing that, but then there's just an extra step of rebuilding the path back from the BFS. It's a little bit more complicated. It is a better solution, but it's a bit more advanced. So, like, I would first make sure I can get it with the DFS, or sorry, with the
Yeah.
backtracking.
Yeah, I did knew it was somewhat similar to backtracking, but I just haven't. I forgot how to do that problem. I haven't studied those in a while.
Even with a lot of the BFS, like, this is sort of a really bad way to do it. I mean, maybe not
Yeah.
terrible, but um, having like an array for each element where you're storing the
Yeah.
path, and then you just keep
Yeah.
appending. That's one way to do it, but it's gonna take up a ton of space.
Yeah.
But there's like multiple ways to do this. Like, try out this question by yourself. Try
Mhm.
out the backtracking, get it fully implemented. Try out the BFS, and then try to figure out how you can build the path. But yeah, the hard part of this, because if I just told you return true if we can get from the top left to the bottom right, you'd have done it easily. But when I
Yeah.
said give me the path, that's when it got harder. So yeah, I think it's a fun question. Just
Yeah. It's a good question to code. Just for coding practices, looking all the checking all the like all these conditions.
yeah.
Um,
I think yeah. Overall, like, the code looks like you know how to use the visited. One thing I would do with the visited is usually I add visited the moment I pop them into an array. So it'd probably be like
Mhm.
in here and like in here.
Okay.
That's when I usually add visited for simple BFS and DFS.
Mhm.
Because if you only add it after you visit a node, you're gonna get a queue with way too many nodes. Because
Right.
pretend I have two of the same, or visiting two nodes that have the same neighbor. If I pop their neighbor in only after we visit that neighbor is gonna get into the queue at least twice.
Mhm.
So it's like I've done questions where it ran out of time or space because I wasn't managing the visited properly. So that's just more advice on that end.
Okay.
Yeah,
Yeah, that was really helpful. Yeah. Thank you very
cool.
much.
Yeah, go ahead and try this out and let me know how it goes. Send me an email with your code. I'm curious to look at it when you're done.
Okay.
All
I'll
right.
try it out.
Okay.
Thank you.
Thanks, son. See you.
Bye.
Bye. All right, we got the last guy. Oh, my eyes is burning. Drink some water. Yo, chat, when I turn on the fan, can you hear the fan in the background? Like, the fan's on right now. Alright. Holy crap. Yo, what's up, man? Long time. How you doing?
Yeah, what's good, bro? Long
Been a
time.
minute. What did I ask you
Yeah.
last time? Was it the infections or something?
It was some tree problem. That was the last one. Basically, if I remember correctly, it was like one of them tree problems where you had to apply like basically an adjacency list to solve the problem. You had to build that.
Mm-hmm.
I
see.
think.
Cool. So, were you able to solve it after, or did you study?
Yeah,
anything
I
after?
was. Yeah. I had to go. I realized like I didn't know much about like adjacency lists, so I had to, go learn that
Yeah.
basically.
All right.
Yeah, and-
I forget, like, what are you interviewing for again, or yeah, what do you want to study?
So like right now, like well, based right now I work for myself, right?
Yeah.
But like I am actively looking for roles. It could be FANG, it could be regular companies, startups. Like I don't really have a preference. Like anything goes, to be fair.
I see. Okay.
I think you sent me the link. Yeah,
I sent you
I
the
think
link.
yeah. Yeah, I switched to Python for like DSA.
Nice.
Yeah.
Just to be faster, honestly.
Yeah, honestly, that's why I switched. Yeah, it's just to be a
Did
lot
you
faster.
notice you're a lot faster?
Yeah, I realized that. I realized that. Yeah, definitely. Like, it's basically.
What were you using before?
It was Java. I was
Yeah.
using Java before.
So, yeah, if you
Before.
already had a lot of experience in Java, like I wouldn't switch. But like, for some people, when
Yeah.
they just started, I was just switch.
Yeah, no, I agree. The reason why I switched, because like, not every problem like you clock the algorithms straight away. So like, you might implement an algorithm and halfway through, you'll be like, oh shit, this is wrong.
Yeah.
So like, the thing with Java, or at least I felt like you have to type more, which means you eat up more time and stuff.
Yeah.
So I was just like, oh, Python, just in case that happens.
Yeah. How long you been in the stream? Have you seen like all the questions being asked and stuff?
So like I joined earlier. I was probably there for like maybe 10-15 minutes, but then like I had to go make food, and then
Yeah.
I started watching YouTube. But essentially, no, I haven't seen all the questions.
Okay. All right. Okay. I'm gonna let me do a quick intro.
Sure.
Everyone, so today we have somebody joining in from Canada. I think you're from Toronto area.
Canada, correct? Yeah, Ontario. Yeah, I live in
Ontario
Ontario.
area. 200 plus leak code questions solved. Self-employed but actively looking, so starting to look for like fan companies and stuff like that. How many hard questions, medium questions, and easy questions have you solved?
Hard questions are probably done. I know it's less than 10 at least. Medium and easy is 100 and something.
100 something.
But like
Okay.
low hundreds. But I don't. I mean, I'll have to search that right now.
Cool.
Like,
Okay.
let me-
So I'm gonna give you this question. So
Sure.
we're gonna be given a list of friends. It's gonna be like given a list of pairs of friends.
Okay.
So it's gonna be like a list, right?
Okay.
It's gonna be a bunch of friends. James, Isaac, Nat. Like random people, right?
Okay.
Maybe. So we're gonna be given a list of pairs of friends.
Okay.
Then after we're given a list of friends, we're gonna have like n queries. Where each query will ask what is the degrees of separation between these two people.
Okay.
Query is the degree of separation between two people. So that means like if me and you are directly friends, we only have 1 degree of separation. If me and you are friends through a mutual friend, we have 2 degrees of separation.
Okay.
Does that make sense? If
Yeah.
you're a friend
yeah,
of a friend
I
of a
think it
friend,
does, yeah.
yeah, exactly.
So like, what am I supposed to output?
So for each query, pretend we say James, Isaac, right? We should output degree of separation, which is 1.
Okay.
What about James and Nat? How many degrees of separation is that?
So I think that would be 2. Assuming like Isaac, well, in this array, assuming they're 2 different people.
Yeah, they're 2 different people. The names here are gonna be
Oh,
unique.
rather they're the same person. Rather.
Yeah, they're the same people. I mean, yeah, the names are gonna be unique.
Right. Okay. Cool. Okay. I'll just wait for you to finish typing.
Yeah, go ahead. I'm just writing down some questions.
Oh, okay. So like, so I'm assuming the names are unique, correct?
Yeah.
Okay. And then I would also be provided like 2 different names in like the method. I'm assuming, right? Correct.
Yeah.
So like essentially like to link both people together. So I'll be giving two separate names, and then I'm supposed to output the distance
Yeah.
between them.
Exactly. Exactly.
Okay, cool. All right, cool. I'm just gonna think for a second here. So essentially, this would be some form of merge sort, I guess. Well, not merge sort. Like we want to basically merge names together, right? And okay, so I'm just gonna do a bit of. Oh, so queries can contain multiple.
It's just gonna be a bunch of queries.
Gotcha.
But like we're gonna be given two inputs, the friends and the queries. We're gonna
Gotcha. Okay.
all we just need to do is loop through the queries, and for each query, like print out the degrees of separation between those two friends.
Gotcha. Gotcha. All right, cool. Sorry, I'm just trying to think here. So, and it's Gary. Okay, never mind. So I'm thinking we build like some form of hierarchy, right, for each name, and then plug them together, right, and then that way we are essentially able to iterate through queries where, um, yeah. So this is essentially going to be my approach, right? So we want to build a hierarchy. So I'm just gonna say build a hierarchy using a map, right? So for example, in this for these two examples you gave, right? So we're gonna have rather not friend, James. James is going to link to multiple people. Well, it could be an array of objects. Now that I'm thinking about this, right? So we would say James links to say give it a name. James links to Isaac, right? And then in the next entry we have Isaac links to give it a name. Say name Nat, right? And then Nat links to an empty array,
Mm-hmm.
right? So essentially, the flow of things is then we would then, after we've built the hierarchy using a map, we'll then iterate through queries where for each name, right, we want to perform a DFS on the hierarchy map or the map, I guess, hierarchy map, whatever you want to call it. We basically do that, and then we then count. Actually, no. Now that I'm thinking about this, that would probably not work because it might give us a okay, no, actually, no, maybe that wouldn't work. Um, hmm, let me think. Sorry, give me a second here, Leo. I'm gonna think out loud for a bit. So, if actually, better question: do you think building a hierarchy could work in this case?
Yeah, building a hierarchy by just using a bunch of sets, or like what do you mean by building a hierarchy specifically?
So like it would essentially be like for each name, right? We want to pair them with all the people they're attached to, so friends. So in this case, James to Isaac, right? And then, well, actually, no, ignore it. I think I have a question here. So can we say, okay, so I know this example is rather simple, but can we have multiple um, instances where James is friends with somebody else?
Yeah, I could
Can
be
we
friends
have
with a
that?
ton of people.
Okay, he can be friends with a ton of people. Gotcha. Okay, all right.
Like James, Patrick,
To Patrick, yeah,
Patrick to Paul,
right,
Paul to Nat.
right. Um, hmm. So if we build a hierarchy, right? Now, if I say James, I want to get all James's friends, right? Yeah. So I'll stick with the approach and trying to explain it to you and see if it makes sense to you. So essentially, I'm going to build a hierarchy for each name. I'm going to link um, the values. Well, because this is a map, so essentially the name will be the key, and then the value would be all their attached friends. So think of it like a hierarchy, right? And then I will then iterate through queries where for each name I would have to perform a DFS until I get the if or like I basically find a friend and basically calculate the distance there. Does that make sense?
Yeah. If we perform a DFS, okay. But what if we, for example, we're looking between James and Nat, right? I mean, there's
Okay,
multiple ways that I can get to Nat.
correct.
I can go James to Isaac, or James to Patrick, Patrick to Paul, Paul to Nat. That's like four.
Right. Maybe
Like the degree of separation is actually two, not four.
correct. So if we say James, okay, so we want to get the next pair, right? The next pair for James. This is a good problem. um, oh my goodness, I don't know why I can't think all of a sudden. So DFS would definitely building a hierarchy would probably not work. It wouldn't be the most efficient. Um, okay, so can we say we have? Can I do a BFS on this matrix graph of friends? So say we have James, right? So James, we get all his friends, right? Or all James friends. So say Isaac, right? Patrick, and then um that's pretty much it, right? So from that point we then just keep performing a DFS. But then or rather BFS, but then the issue then becomes for the queries can be n long essentially. You can have a shit ton of queries. So that would probably not be the most efficient. Hmm. 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 Yeah, actually, why am I worrying myself about efficiency? Can we instead just perform a BFS for say essentially what I'm going to do is for every query, right? I'll pull out the individual um names, right? And then I'll then need to actually no, that wouldn't work. That wouldn't work. That wouldn't work.
What wouldn't work?
Hmm. Performing so essentially for every query, right? I would have to plug out the names,
Yeah.
right? And
Yeah.
then get the associated um name basically iterate through friends where the particular name I'm looking at or index of zero in this case, right? I would have to check all the friends where the index of zero matches the name, and then I'll then basically get the perform BFS on them, all the names. But then I don't think that would be efficient. Actually, do you understand? Did you understand what I just said?
You're trying to say that we can't do a BFS essentially?
I'm saying like, would it be the most efficient?
Well, like if we perform a DFS, the problem is that
No, BFS, breath
yeah.
first. Sorry.
So
Yeah.
yeah, yeah. Like I understand. So yeah, what I'm saying with the DFS, you first the reason why you said you don't want to go with that is because you might return the wrong degree of separation, right?
Correct.
Because um and like why is that the case? Could you explain why you might return the wrong degree of separation?
Because say for every single entry in queries, right? I would have to iterate through friends and then get all the instances where the index of zero matches the index of zero of queries matches the index of zero of friends,
Mm.
right? And then insert that into a what's the word a queue, right? And
Mm.
then perform a BFS where I just basically pass the distance to the appropriate no, actually no, that wouldn't work either. That wouldn't work either because I wouldn't have the instance of said name. Hmm. What am I missing? What am I missing here? What am I missing here? Hmm. What am I missing here? Could it be a thing where I can't possibly merge the names, can I? Like build some form of a linked list with these names? No? You think I could possibly do that for every single name? Right. I want to build like a linked list of all the friends. You think I can possibly do
Build a
that?
linked list of all the friends. What
Yeah,
what would
so
be the
like
use of that data structure?
so it would be easier to find all the names that are associated to every single query, the index of zero. So what I'm trying to get at is if I just do a simple diagram, right? So for say for James,
Yeah.
right, his attached friend would be Isaac, right, and then also no,
And
that
Patrick.
wouldn't work. Yeah, no, that it would also be Patrick too.
Yeah.
Um, maybe not a linked list, but
Yeah.
basically just
Yeah.
an
Just
array of
just an array.
names.
We just need to know for James. These are its friends.
Yeah, these are all his friends,
Yeah.
right? And then for now, the thing is, we would then have to. I'm sorry, I'm just gonna type some things out and then try and make sense of
Yeah.
it in my
Yeah.
head,
Uh,
right? So Patrick. Now, better thing. Say in this example, no, Patrick is friends with Paul. Actually, no, never mind. I was ignore what I said. So let's just say Patrick. His friends are Paul, or rather James, Paul, James, and Paul. I guess. Right? Correct.
yeah.
And then for Paul, his friends are Patrick, Nat, and then for Isaac, we then have James and Nat. So if we build this, right, we essentially want to be able to find the associated friends. So for James, is he friends with Isaac, or the distance, I guess,
Yeah. The
right?
distance.
In this case, right, would be so for James to Isaac would just essentially return one, which is fair. Now
Yeah.
from James to Nat, right? So from James, we then pull out Nat, or rather, we see that Nat isn't in the array of friends. So we will then have to check every single friend. So for Isaac, right, we pull up, move on down to, or rather, we perform a BFS or DFS, I guess, right? And then, okay, so we see James again, but we have already seen James, so we ignore that or
Mm-hmm.
ignore his name, I guess,
Sure.
and then move on to Nat. So we have found an individual. So in our recursive call stack, it should return two, I think. Right. Now let's move on to the next individual. Well, I guess those are the only two entries.
But what
But
if
then
I
like
go instead of Isaac? What if it was Patrick actually here first?
if Patrick was here first, so we would then have to go to for Patrick. Then we move on to Patrick, and then we check all his friends. We ignore James because we have already seen James, and then we move on to Paul, right? And then Paul leads us to Nat.
Yeah. But
But
then
then,
the
yeah,
degree of
that's
separation is too big.
it is yeah,
It's
exactly.
not good.
Degree of separation is three, but we want two. So in this case, um can we do something like instead of a DFS, can we perform a BFS, I guess?
Mm-hmm.
Can,
Like, why
because
would
the
that solve
BFS will
it?
get a BFS will get us the closest name, right? For I mean, like, yeah, I think it might get us the closest name, I think. But basically, we would have to perform BFS on this angle and then passing the distance. So from Patrick to Isaac, right, we get James and Paul. We ignore Paul. Um, Now from Paul we get Nat, but we see that is three. Um, can we do something? No, that would. I might not know how to solve this question if in in the right time. Hmm,
Makes sense. Like
huh.
yeah, like the problem with the DFS is that if we do a DFS,
Right.
it we might take a path that's too long, and we return
Correct.
the wrong result. So breadth first search usually gets us the shortest path between two
Correct.
names, and then we just return that. So yeah, BFS makes sense to me.
Yeah. But then like the only question I have for that is how do you then keep track of the the weight of the distance? So do you
The
use some do you use like a priority queue for the as a queue when performing BFS? Do you
pro-
understand what I just said first?
no, I didn't get that. What did you say?
Oh, okay. So say in this case, right, if we're going to perform BFS on um for, between James and say Nat,
Yeah.
right? So we basically iterate through the closest friends to Patrick, or rather James. It would be Patrick and then Isaac.
Mm-hmm.
But then we pass the distance, which in this case it would be 1 to 1 for Patrick and Isaac,
Yeah.
right? Does that make sense? That's
Yeah.
what?
Yeah.
Right. And then from Patrick, we then move on to James. Well, we ignore James because we have already seen his name. And then we pass on 2
Yeah.
to Paul because of 1 plus 1,
Yeah.
right? And then we then pop out of the queue and then handle Isaac, right? So from gotcha, I see that actually. I see it actually now. A BFS would work here.
Yeah.
Yeah, BFS. Yeah, this is a BFS question. Yeah, I see that now. I see that. I see that. I definitely see that. Yeah. I mean, I don't. Do I have time to implement?
Yeah. You have time. You have time.
Oh, okay, fair enough. So I could just jump straight to coding as long as
Yeah.
you
Go ahead.
already
Like
understand.
you're. Yeah. What?
Okay,
Yeah. Go ahead.
fair enough. I'm just gonna call this solution, and then so say we are giving friends, and then we're giving queries, right? So what do we want to do? We basically want to build the um, this data structure, right? So I think I need a map here. So I'm just gonna call this
Mm-hmm.
cache, right? Actually, maybe I should use default. No, default dictionary. Yeah, I think it's default dictionary should work. Yeah. So okay, now I want to iterate through friends. So for friend in friends, um, yeah, for friends in friends. Actually, we could do this instead. So we can say first uh friend one, and then say friend two, right? And then what do we then want to do? So we basically want to build a thing. So we want to say cache dot friend one dot append friend friend two, and then we want to say cache dot friend two dot append friend one. So this is essentially just building the adjacency list. Hopefully this makes sense to you thus far.
Yeah. Yeah.
Right. So now we then want to iterate through queries, right? To basically find the closest distance, I guess. So what do we then want to do here? So we want to define our query, or rather a queue here. So we're gonna say DQ, right? And then, so what do I then want to do? So I want to say iterate through, say F1 and then F2 in queries, I guess. So what do I then want to? I want to find the distance, right? Now that I'm thinking about this, how do I want to perform my BFS on this? Right. So I'll just do q dot append um, f1, I guess. It'll be a tuple. So let's just say f1, and then give a distance of initially 0. Then I'm then going to perform a BFS here, where I'm saying whilst our queue is not empty, right? I would define, I'm going to call this friend, and then distance, I guess. call this equal to q dot pop left, I guess. Let me think about this properly first. So we have said individuals. We have said individual, right? So the friend and then F2. So what do we want to do? We want to perform a BFS on these names. So how do I do that? Instead of appending the name, I would have to append all his friends. Correct? So instead of doing this, it would have to be so for say cache dot f1. Let's do friend.
One piece of advice here would just be probably pull out the BFS into its own function.
Okay, fair enough.
Because you're gonna perform a BFS for every query.
For every single query, yeah. That was my worry initially, because like that might not be the most efficient, but who cares, right? So let's just do cache, and I need F1, and then let's just say F2. Right. So now what do I then want to do here? So I essentially then want to say, okay, cool. Now that I have the friends, I'm going to append. First of all, I need to clear the queue just in case we have items in the queue already. Then I want to then append. Actually, I don't have the instance of the queue. Okay, so what do I then want to do?
Why do you need to pass in a queue there?
Because I am performing BF. I mean, unless I'll have to create a new instance of the queue every single time. So that's the reason why I'm clearing the queue, so I don't have to create a new instance. Does that make sense?
Yeah, but if we need a brand new one every time, why not just create it?
Yeah. Oh, okay, fair enough. I mean, yeah. Okay, that's fair. And then, okay, so now that we have our queue, hopefully I'm still within the time frame. Okay, so what was I doing? So I basically want to then append all the friends into the queue whilst passing the keeping track of the distance. So I'm just gonna iterate through cache. Let's do f friend in cache of f1. And then we can then say q.append, append f, and then give a distance of initially 0. So now that we have this, so I'm then going to say whilst we have a value in our queue, right, I want to pop out the friend. I'm going to give this a friend, just call it f, and then the distance, right, equal to q.pop left. Right now, I then check the case if f is equal to f2. I'm just going to return the distance. Else, I basically want to then perform a BFS on every single friend's friend or friends. So what do I then do here? So I basically say friend. Gonna call this a neighbor in cache of f. I also need a scene. Scene equal to sets. Actually, now that I'm thinking about it, I could just pull this down like this. So now that we have this, oh my goodness. So now that we have this individual, what do we want to say? So if f in scene, we're just going to continue because we don't want to, search the same friends.
Sure.
I'm also going to do this for this also. I can call this neighbor instead. Right. So now that we have the friend, so we're basically then going to append it into our queue. Right. Which would be q.append. I think I've seen an optimization I can possibly do here even. So we can then do the distance plus 1. So I think this this should return the answer. The optimization I actually just thought about was what's the word? So instead of this, because it's not gonna matter because we're not gonna add this. I'm gonna move this also, and then I'm just essentially going to do if f, or rather, should it be f or neighbor? Actually, no, I'm just gonna leave it the way it is, right? And then just leave it the way it is like this. Right. Yeah, so this would definitely be my solution. I'm gonna carry on with the just the final few bits, and then perform a BFS on right hand side. What am I passing in cache? I'm passing F1 and F2. Right, and then I'm assuming the results should be an array of items, correct? Or array of distances, correct?
Yeah.
For every single query. Okay, cool. And then I have my results is equal to an empty array. Just gonna return this. Call this our results. And then now that I'm actually deep in this, it should probably be yeah. So this would be a return value, and I can just do res dot append this value. Does this make sense thus far?
Yeah, it makes sense thus far.
Right, it should be default. I think this is how. No, maybe it's this way. Right, and then yeah. So this would be my solution to the problem. I don't know if you want me to dry run the code.
Let's actually just run it through some inputs and assert that
Sure.
it's correct.
Sure. Okay, cool. Fair enough. So I'm just gonna do print solution, and then gonna call this friend, and then Q. I'll just define the and then Q. Let's go to this. And then the examples you gave were these. Back to here. Give me a second here. Just like this. There we go. And then so the expected output in this case should be 1 and 2. Okay, so it says F1 append. Okay, so where maybe default, I forget am I allowed to look up the API? I could do something similar to this, but then that would be yeah. I was gonna look up the API. Yeah. Thanks. Yeah, list. Yeah, there we go. So that should be okay. So it's off. Okay, so let me do a bit of debugging here. So just make sure this prints the expected output here. Let's just make sure. So we have James, Isaac, Patrick. Cool. All right, cool. So the problem then boils down to my BFS function. All right, cool. So looking at this, right? So I then append for every single name for the associated friend, right? I need to get all the friends, cool, and then I iterate through the distance or iterate through the queue, and then basically check all the neighbors. Okay. So now I'm just do if not in scene dot add. I think this was where the issue was. And then I also need to actually no. This I think I've seen the error here. So this should be down here because I'm revisiting old names I feel. So let's see.
I don't think that's the error.
Okay. What was the output? Okay, it's still the same thing. All right, cool. So I have my okay. Loop through the neighbors. If neighbor not in scene, I can then passing okay into our queue. Cool. Um, pen of friends. Cool. Okay. So what is this queue looking like initially? What is this looking like initially? So we have Isaac, Patrick, Isaac, and then Patrick. Cool. So that isn't what I want. Hmm. Wait, give me a sec. So James to Isaac, and then James to Nat. Looking at this, James to Isaac should be okay. I think I've seen the problem. So we should start off with 1 instead of 0. I think. So I think that's where the problem is. So it should be 1 to 2. Okay, cool. This I think this looks about right. I'll try for a different example here. So say we have just say James is not friends with Nat, I guess. So let's just take this out. James to Isaac, and then James to. Actually, I don't know if I should make my own examples. It should be you.
No, you should make your own example.
Oh, okay, fair enough.
Just test it and make sure that it's working correct.
Yeah, okay, fair enough. So essentially, James to Isaac, right, should return 1, right, and then James to Nat should be 0. So the expected output should be 1 to 0. Okay. Instead of none, I see. So this should be I see what my problem is. I return a base case here. It should be 0. Right. Yeah, so this is then the expected. So yeah, this would be my final solution, even though I had a lot of hints from me.
Yeah.
But yeah, so this is my final solution for sure.
Nice. Yeah, it's looking good. It's looking good. Let me think about this. Yeah. So maybe one follow up would be pretend there was I don't know if I would follow.
I mean, maybe actually, a question I should have asked earlier is: it's not possible for James or for a person to be friends with themselves, right? So like,
Yeah.
I should have clarified that, but I don't know.
Yeah.
Yeah, I should have clarified that.
Okay.
Yeah.
Cool. All right. How do you think you did? How was that?
Yeah, I need a bunch of hints.
Yeah.
I don't know. I feel like it's just because I honestly have no as far as my feedbacks, if anything, like I should have I should do maybe attempt more questions, I guess. Maybe communicate better. I think, but I don't think I did that well, to be fair.
Yeah. I think the main thing you could improve on here is you should, when you start reading through the question, and it says degrees of separation, or like they're showing relationships between two elements or two people, you should start thinking about it as a graph question right away. And I think you had trouble identifying that at first.
Yeah.
So this is a graph question because like if you come into the drawing.
Just give me a second. Yeah. It's loading up. Yeah, I'm on the same page.
Like this is a graph question because yeah, every person is a node in the graph, James. Right?
Right.
Isaac. Patrick. Oh sure. Like everybody is a node in the graph. Patrick.
Right.
Paul. Nat. So it's like a bi-directional
relationship.
It's usually a bi-directional relationship between each person in this graph.
Right.
And it's like let's say we have this. So once you can visualize in your head that this is actually a graph, then you need to start figuring out the degrees of separation. Between James and Isaac, it's 1. Between James and Nat, it's 2. So I think the first step is identifying it's a graph problem faster, and just
Right.
like visualizing the graph in your head. And after
Right.
that, yeah, like you explored, oh, maybe we need to do a DFS. Okay, if we do a DFS, but what if we are looking for James and Nat, we go the long way, right?
Right.
So yeah, and then like what I think for me, when I visualize that it's a graph in my head, then I need to figure out, like, even if I just drew out the graph like this, then I know, okay, James and Isaac, in order to find the shortest path, we just do a BFS. So it took you a while
Right.
to just determine that we actually need to do a BFS.
Right.
To
Yeah.
solve it. And I think it just stems from just like not identifying it's a graph problem right away.
Right. Yeah. No, honestly, I should have clocked that it was a graph problem because they said or rather, a BFS off the top because they said the shortest path.
Well,
Right.
I just said degrees of separation, so it's not really shortest. Like I didn't directly say the shortest path between two. Otherwise, you would have thought BFS right away.
Yeah. Yeah. No, I mean, like I'm just saying, like I should have clocked that, but either way, like this was good though. This was really good. Yeah.
I think you learned a lot from last time too, like building out the adjacency list and.
Yeah.
BFS was pretty
Man, I should have
good.
knew that would have been the same question you would ask. They'd be in the
That's a
same
good question.
topic. Yeah. But yeah, that's fair. This was good though. This was good.
Cool. Yeah. But honestly, like good clarifying the questions, figuring out all the different constraints, like the names being unique, like the different queries. Yeah, just ironing out the requirements of what even is a degree of separation and the input. I think
Right.
I gave you some prompting to like break out the BFS into its own function. So if you're gonna perform a thing multiple times, might as well break it onto its own function, have it isolated.
Right.
You did a weird thing with you're passing in the queue and clearing it, but really each
Yeah.
BFS should just act unique. It's like should be like a unique call, and it shouldn't
Yeah.
reuse data structures. It shouldn't reuse like values from a previous run because the previous run doesn't really matter for the current run.
Yeah. Yeah. No, that's completely fair. Yeah. I mean, like the way I was just going to approach it before, it was, just clear the queue every upon every iteration or the set.
Yeah.
Clear both of them every iteration.
Yeah.
But yeah, I can see that. I see that for sure. I see
All
that
right.
for sure.
Cool.
All right. Yeah.
Thanks for hopping
This
on.
is good.
Yeah. Let me
For
know when
sure.
you want to do another one. Just schedule one through. Like you're honestly getting better.
Yeah,
each
for
time,
sure.
So. Cool. All right. See you, man.
All right. Yeah. Peace out now.
All right, chat. That was 4 interviews in one day. Man, that was fun. We got a lot more tomorrow. I gotta do some prep. I gotta do some prep for some people we have on tomorrow. Tomorrow I have a special guest. So one of my friends, when he went to University of Pennsylvania, and while he was in school, he started a startup with some of his other friends and sold the startup while he was in school to Lyft. So he already had a successful exit before he left school, and then he came to Silicon Valley. That's how I know him. I worked with him at my first job. Then he moved to Airtable and is working on he's working on AI. He's an AI engineer now. So he transitioned from a SWE to an AI engineer. I don't think he does code forces. So we're gonna figure out what topics to talk about. Yeah, but Josh, did you book with? Yeah, second was Alpha. Josh, have you booked at all? Oh, who's the most cracked so far? Alpha's up there for sure. Obviously, Codeforce's guy. But Codeforce's guy doesn't really do the lead code questions. So if you ask him some lead code questions, he might not know it. He'll be able to do it, but the type of questions Codeforces ask versus lead code are very different. But anyways. All right. Anyways, chat. Thanks for hopping in. That was a good stream. We'll be on again tomorrow from will be on tomorrow from 5 to 10. Yeah, and we got a bunch of people. We have that. I'm bringing on that AI engineer. But yo, thanks everyone for coming out. If please, like, if you find any good interview questions that people are actually being asked, send it to me. Maybe I'll make a new chat in the Discord where people are posting real interview questions that are getting asked, and not just like these random like lead code competition ones that are kind of whack. But thanks for tuning in. I'll catch y'all in the next stream.
This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode. This is not my main thing, really I'm a coder. Coffee stains and name chains, I am such a loner. San Francisco bases got me slowly taking over. I can't wait to show you that I'm gonna take it over. Lico, beast mode, 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 Lico, beast mode.